Welcome to my YouTube channel, Brainy Course. Please like and subscribe my channel. Your support is the foundation upon which we build captivating content. Thank you for subscribing and being part of our creative fortress.
So much of what you take for granted in your everyday online life, like using a search engine, shopping, and using social media, is made possible by JavaScript. Nearly all of the interactivity you experience online, like drop-down menus or the autocomplete function, is facilitated by JavaScript. JavaScript is most well known for being the programming language of the web, but it has become so much more. Now, it is used not only for the front-end development, but also for back-end development, and you can even create mobile apps using JavaScript and React. Without JavaScript, the modern software development landscape would look a lot different. Because it is such a powerful tool and so integral to software development, it is important for you, as a new developer, to know how it works and how to use it. In this course, starting with Module 1, you will cover an introduction to JavaScript that will help you understand how it is used in the real world. And you'll learn how to set up Visual Studio Code and install the Code Runner extension. This module also introduces you to programming in JavaScript, which includes learning about variables, data types, operators, strings, Booleans, and numbers. After this, you'll progress to learning about conditional statements and loops. And in Module 2, you will build on what you've learned in the first module by learning about arrays, objects, and functions. You will also learn about bugs and errors. In Module 3, you will learn about the functional programming and object-oriented programming paradigm, which includes function calling, recursion, and scope. With scoping, you will learn how to use var, let, and const. Furthermore, you will learn about object-oriented programming, and you will design and build an object-oriented program. You will also learn about advanced JavaScript features, like destructuring arrays and objects using for-of loops and template literals. Additionally, you will learn about data structures and the spread and rest operators. You will also learn how JavaScript is used in the browser. In this module, you will have an opportunity to practice updating the contents of a web page. Module 4 is all about testing and compatibility. Therefore, you will learn about types of testing and you'll write a unit test. You will also be introduced to Jest and learn how to write tests with Jests in an exercise. And you will learn about test-driven development and get to practice applying it too. You will also learn about JavaScript testing challenges, which include learning about Webpack, transpiling, and working with arrow functions in React. As part of this module, you will also learn about other JavaScript environments like Node and NPM. In Module 5, you will have an opportunity to put your new skills into practice by creating the Little Lemon receipt maker. In summary, this course provides you with an introduction to JavaScript. It is part of a program of courses that leads you towards a career in software development. You have probably encountered many new technical words and terminology in this video. Don't worry if you don't fully understand all these terms right now. Everything will become clearer soon. After all, this is part of the reason why you are taking this course.
Anytime you're using a browser, anytime you're browsing the internet, you are using JavaScript. It's the language of the internet. Hey, students. My name is Murtada. I'm a software engineer at Meta based in the Seattle office. I've been coding in JavaScript since 2012. So JavaScript is actually something that, as you're watching me now through this video, it's something that you're using. Probably as you made your coffee this morning, maybe your coffee maker had some JavaScript. Your car might have JavaScript. Nowadays, we are in a world where JavaScript is so common and so used across a lot of technologies and a lot of devices that it's become a language that cannot be replaced. The first time I used JavaScript was I was an intern at the time, Facebook. And at the time, JavaScript had not been as popular and as common, so I hadn't actually learned it in university or in my courses. You know, the other more attractive or interesting languages at the time were like people writing in Java or C++. People used to sometimes not take JavaScript very seriously and think like it's a language that's not used by real and serious developers. But now we see the world runs using JavaScript, and just about every application we interact with today probably has some JavaScript in it one way or another. One of the things that makes JavaScript so popular and important is that it's the only language that is used in web development. In game developments or other types of applications, there are choices to use other languages, like you could use C++ or you could use Java or you could use other things. But when it comes to web development, the only available language is JavaScript, and that's what makes it so popular and common and important to learn when you're developing web applications. At Meta, we use JavaScript in our entire web stack, but we also use JavaScript in other places too. One of the unique things about JavaScript that no other language has is that it's a language that can be used for writing the front end and the back end. So a lot of applications, they have a backend maybe in Python or PHP or Java or something else, but they're required to have a JavaScript front end because that's the only language of the front end. But because JavaScript can also be used on the back end, if you design your application or if you choose to make it consistently JavaScript across the entire stack, sometimes that may simplify the application, and then you don't have to learn multiple languages or maintain code bases that are written in different languages. Some of the challenges that I've faced when switching between other languages, like I had been used to Java and came to the world of JavaScript, even though they seem like they might be very similar, they're like half of the name is the same, but actually it turns out there are some things in JavaScript that are specific and they're very unique to this language. There are certain things about JavaScript that are a little inconsistent when compared to other programming languages. Like you have your C++ and Java and some other languages that follow certain behaviors, and then JavaScript is sometimes in its own corner doing weird things. But I actually find that a lot of times JavaScript is easier to learn than some of these other languages. So even if in its weirdness and in its quirks and some of the things that are confusing about it, overall, I find it an easier language to learn and use than these other ones. As you're learning JavaScript, you'll stumble upon challenges, and you might find that things are not making sense. I encourage you to power through them, and you will find that with time, you will likely come to enjoy and love this language. At this point, we live in a world where JavaScript is so commonly used across devices and technologies. I can't comprehend or think of all the different applications or places that are running JavaScript in them. As you, a developer who is learning coding, it's an important skill to have, and you'll find that many employers will be interested in hiring you if you can code in JavaScript. So, give it a shot and be patient with it. If it confuses you or frustrates you, don't let that stop you from going through. Do we do the thing at the end too?
So you're ready to start programming with JavaScript. But before you can begin developing projects with JavaScript, you need to set up software called VS, or Visual Studio Code. VS Code is a code editor that developers use to write their JavaScript code. By the end of this video, you'll be able to install VS Code, Node.js, and the Code Runner extension on your Windows operating system. Start a new JavaScript file in VS Code and run the file using Code Runner extension, and explain what console.log does in JavaScript. Let's begin by exploring the VS Code download and installation process. First, I open a search engine in my browser and search for the term VS Code, or Visual Studio Code. I click on the first link, which directs me to the official website at code.visualstudio.com. This link redirects me to the site's homepage. On this homepage, I select the Download for Windows button. A message appears on the VS Code website, which states, "Thanks for downloading VS Code for Windows." I can then track my download progress in my browser. Once the file is downloaded, I click the file to begin the installation process. The license agreement appears. I read through the agreement and select Next. I then accept the default installation destination and the Start menu folder. I also select the following additional tasks: create a desktop icon, add Open with Code action to Windows Explorer file context menu, add Open with Code action to Windows Explorer directory context menu. Once I've selected these additional tasks, I click Next. Now that I have configured these tasks, I select the Install button. Once installed, I then check Launch Visual Studio Code and select Finish. My Visual Studio Code program then appears in a new window on the Get Started page. From here, I click the bottommost icon on the very left of the VS Code window to open the Extensions panel. Once in the panel, I type Code Runner to search for the Code Runner extension. I then select and install this extension from the search results. While the extension installs, I return to my browser and search for node.js. I access the file from the official site at nodejs.org and click on the direct download link, making sure to install the Windows version. A pop-up appears on screen to track progress of the download. Once the file has downloaded, I select Open File to open the node.js setup wizard. I then select Next and accept the license agreement. I then click Install to begin the installation process. Once the installation process has completed, I click the Finish button to close the setup wizard. I then return to VS Code, where the Code Runner installation process is complete. To confirm that Code Runner is installed, I can check for the following message on screen, which states, "This extension is enabled globally." Just to the right of the Code Runner tab is a stripe for the files. I double-click this to open a new file. I then click Select Language and choose JavaScript from the list of languages. I can also type JS in the search bar to narrow my results. Next, I close the Code Runner tab and click on the Extensions icon to toggle off the extension sidebar. I then click on the View tab and select the Terminal option to open the terminal that I closed earlier. I need to clear the terminal. I can do this by typing clear and pressing the Enter key. Next, I hover over the terminal's Output tab. I then click, hold, and drag it to the right in order to dock it on the right-hand side of the VS Code window. Now, I close the terminal again. The output should remain on the right-hand side of the screen. I can also adjust the width of the output by dragging the split to the left or right. Finally, I type some code into the tab Untitled1 as follows: console.log, followed by a pair of parentheses in which I type Hello World in single quotes. To run this code, I click the play icon. I can also use the shortcut keys Ctrl-Alt-N. The words Hello World appear in my output. Other information also appears, but Hello World is all I need to focus on for now. And that's it. I've successfully set up VS Code with Code Runner. You now know how to install Visual Studio or VS Code, Node.js, and the Code Runner extension on your Windows operating system. You can also start a new JavaScript file in VS Code and run the file using Code Runner extension. And you can explain what console.log does in JavaScript. Great work! Hello and welcome to this video about coding. Let's get started. In this video, you will learn how to interpret the role of programming in the modern world. Recognize that programming is simply giving computers a set of instructions to complete using a programming language, and explain how a programming language like JavaScript helps us tell a computer what to do. Meet Jane. It's Jane's day off from work, and she has 3 things on her to-do list: buy groceries, track her heart rate while exercising, and buy flowers for her friend. At the grocery store, the cashier needs to use the barcode reader to get the information and prices for each of the products Jane wants to buy. The cash register adds up these prices, calculates tax and possible discounts. It then prints out a slip with all the relevant information listed after Jane pays with a credit card. Later on in the day, Jane uses her smartwatch to track her heartbeats while exercising. The smartwatch is synced to her personal profile on a social fitness app, and she chooses what information about her activities she discloses, and she also gets to choose who sees this information. Lastly, after finishing her exercise, Jane orders flowers for a friend online. For many people, just like for Jane, our daily activities are intertwined with computers and computer programs. A computer program is just a series of instructions based on some rules. These instructions tell a computer what to do under some specific circumstances, and they are written to perform a specific set of tasks. For example, when Jane is buying groceries, there was a program that could take the input received from the barcode scanner and convert it to a price for each item. The cash register program instructed the printer to take these prices and print them out, together with some other calculations. When Jane was paying with a credit card, the point of sale machine contacted another program somewhere else. This program took care of all the bank processing and updated the balance on Jane's account. Yet more programs were involved in her smartwatch tracking her heartbeats. Finally, for Jane to be able to order flowers for a friend, a lot of other programs on many different machines were involved. These might include satellites or some other telecommunication computer programs. All these programs are called software and are, in one way or another, running on physical machines which are referred to as hardware. Programming is simply the process of writing the steps a computer needs to take to complete a certain task. To program these instructions, we use programming languages. A programming language is sort of like a bridge that we use to facilitate communication between computers and people. For a computer to understand a programming language, it needs to save it somewhere in its random access memory, RAM, or on a disk, in binary code, which is represented by a series of zeros and ones. The binary code is a representation of machine language that a computer can understand. All of the zeros and ones in binary language represent electrical switches. Finally, a computer's central processing unit, or CPU, can comprehend these binary electrical signals and update itself accordingly. This machine language, with its series of zeros and ones, is known as a low-level language because it's closer to being understood by a computer's CPU. There are also high-level languages, such as JavaScript, that needs to be interpreted. That is, converted to binary code that a CPU will be able to work with. So, we might think of JavaScript and other high-level languages as a tool that helps us to communicate with a CPU. As you saw with Jane's example, computer programs are everywhere. So programming is a very exciting field that touches almost all aspects of the modern world. And now you are on your way to becoming a part of that world as a developer. In the last few hours, or maybe even in the last few minutes, you've probably interacted with web pages to do things like watch videos, look for locations on maps, or interact with your social media feeds. In fact, you're doing it right now with this course. But what makes this interactivity possible? The programming language JavaScript. Let's find out a bit more about the benefits of JavaScript and its importance to developers. JavaScript is a language that builds interactivity into web pages. It is literally the language of the web. Almost every website runs JavaScript in some form or another. The reason for this is the fact that since its very inception in 1995, JavaScript has been the main way to interact with web pages on the client side, the front-end side of websites and web applications. Using JavaScript, updates are displayed in real time on our devices. Some common examples include interactive maps and client-side form validation. Over the years, there have been some alternatives to JavaScript, such as VBScript and more recently, TypeScript. But even TypeScript compiles down to JavaScript, so browsers can understand it. Since JavaScript is one of the most widely available and frequently used methods for interacting with the browser on the client side, the language became immensely popular. In fact, developer surveys often show that JavaScript remains one of the most popular programming languages today. So, What is it that makes JavaScript so integral to modern browsers? JavaScript is currently the only computer language that allows us to directly interact with our web pages dynamically on the client. It's baked into the browser. Its enduring popularity is down to the rules of backwards compatibility, which state that all websites that were built in the past still need to work today. So, removing JavaScript from the browser would effectively render millions of websites completely useless. This means that JavaScript is in the unique position of being one of several central pillars of web development. You've just discovered the importance of JavaScript to web development. JavaScript's unique ecosystem is one of the main reasons for its popularity. Simply put, browsers speak JavaScript. But there are a few other important reasons why we should embrace JavaScript. One of the main reasons that developers use JavaScript is because of how easy it is to use. There are many programming languages where a newcomer needs to do a substantial amount of prep work to even get set up and ready to learn. However, with JavaScript, it's as simple as opening the browser's developer tools and navigating to the console tab, because every browser has a JavaScript engine built in, and you can interact with it using the console. There are still a few small steps required to get started with JavaScript. These include installing a code editor and possibly setting up some other things such as Node.js and npm. But initially, as a beginner, it's enough to just open the developer tools on your web browser. Another reason to learn and use JavaScript is because, as we saw earlier, it's everywhere. JavaScript is used in almost every website there is. It's used on the client side of sites as plain JavaScript, also known as vanilla JavaScript. It fuels a myriad of JavaScript frameworks such as React, Vue, and D3. And it's also used on the server as Node.js and more recently, Deno. Another reason why people often choose JavaScript is that it's considered one of the more accessible programming languages. It also has a wide development community to offer help and guidance. This is especially true when it's compared to other languages. There are many languages that, for a variety of reasons, would be very challenging to begin programming with. But because it's so approachable, JavaScript can be a great way for new developers to jump into programming. So, besides being a useful skill on its own, JavaScript can also be a stepping stone to other languages and technologies. Finally, one more reason to learn JavaScript is because JavaScript skills are in demand. Countless job postings appear for JavaScript developers every day, and these will keep coming for the foreseeable future. So, next time you ask why choose JavaScript, remember that it's the foundational technology of everything you do online, with a huge variety of uses. Plus, it's easy to get started with, and once you're up and running, there's lots of job offers and projects open to you. Best of luck with your JavaScript journey. JavaScript is used in many scenarios, for example, in the browser to help add various kinds of behaviors and interactivity, like adding an item to a shopping cart when you click a button. On the server, it can be used to power up websites, communicate with databases, and provide a native feel to web apps. It's used to build mobile apps using technologies like React Native, and it's used to program devices known as the Internet of Things. In a nutshell, JavaScript is everywhere. This means that there are many different use cases for JavaScript. And with these different use cases come different implementations, each geared towards solving a particular problem. For example, in the early 2000s, different companies built internet browsers and were referred to as browser vendors. However, with different browsers came different behaviors with various discrepancies between other browsers. This resulted in developers sometimes having to write separate JavaScript code for different browsers. This wasn't the best use of developer time and could lead to a frustrating experience for end users. Out of this frustration, several projects appeared, trying to solve this compatibility problem. One such project managed to solve these issues, and it was a library named jQuery. Using this library, all a developer needed was to import jQuery and write code using its features. This code would then work across all browsers. At the time, it was like magic, as it was such a great solution to the problem of incompatibility. And jQuery became the most popular JavaScript library for well over a decade. However, as the web and the way we code kept evolving, new problems appeared, and soon enough, new solutions to those problems needed to be built. One such solution was React, which came out in 2011, and it had a considerable effect on the way we think about websites and how we build them. React solved many of the issues associated with creating, updating, and maintaining complex websites. Soon, many other technologies appeared, attempting to do the same. These include Knockout, Backbone, Angular, Ember, Vue, Alpine, and others. With millions of websites containing JavaScript code from different versions and libraries, there is a lot of old code. This is known as legacy code. While you probably won't use jQuery to build a modern website today, you might still come across it in a project that is still actively running. But don't worry. Sometimes beginners think they have to learn or even master all the different technologies associated with JavaScript. However, that's not really necessary. To be a well-rounded developer, you need to learn and master the basics of plain JavaScript without the frameworks. Once you have this foundation, the pathway will become easier for you to learn a framework built on top of JavaScript, such as React. When you start programming in JavaScript, it helps to think of an empty JavaScript program as the first level of a sandbox game. The world is still empty, but there's some underlying structure to it to build on. That structure needs to be there so that you can write custom JavaScript code in the first place. However, besides the underlying structure, a new JavaScript program is kind of like a blank slate for you to build on. It's up to you, the programmer using JavaScript, to say, let's build this world. And an important part of this process is knowing how to use variables. In this video, you will learn how to identify what a variable is and why you need it, distinguish between variable declaration and variable assignment, and describe how to get a variable's value and reassign it. Let me demonstrate this now, using some code to assign a value to a variable and output it to the console. Right now, I have the Developer Tools panel open in my web browser. You can access this by pressing F12 on Windows and Linux or Command-Option-I on Mac. Then I select the Console tab. This works with any browser, and for this example, I'm using Google Chrome. Now I want to give JavaScript some idea of what I want to build, and I start by adding a person's name. I do this by typing John in double quotation marks. JavaScript receives this person's name and accepts it. There are no errors. This means I've given it some valid data, something that JavaScript can work with. Now let's say that I want JavaScript to say, "Hello, John." In other words, I want it to use the name that I gave JavaScript and I want it to greet the person. But how do I do it? If I type "Hello, John," I'm just typing the whole thing myself. I really want JavaScript to use the name I provided so I don't have to keep retyping it. And this is where variables come in. By using a variable, I can save the name John so that I can reuse it in the future. To save this name in a variable, I'll start with the keyword var and use it to signal to JavaScript that I'm giving it a value that I want it to reuse. To declare a variable, I type the keyword var. Now, I need to declare a fact about this world that I'm building. So I type person, semicolon, and press enter. Great. I've just declared my variable, person. I've given JavaScript one fact about the world that I'm building. The fact that there is a value that I'd like to reuse and that this value is accessible using the word person. Thus, I have completed the variable declaration. However, I still haven't given a name to the person variable. In programming jargon, I'd say that the person variable hasn't been assigned a value yet. The person variable is still undefined. In other words, for the person variable to hold the value of John, I need to assign the value of John to the person variable. To do this, I'll use the assignment operator, the equal sign. Operators perform certain operations, and the assignment operator's purpose is to take the value that is on its right and put it into what is on its left. So, to assign the name John to the variable person, I type var, person equals John in between quotes. I've taken the value John and assigned it to the person variable using the assignment operator. To confirm that this is really the case, let me inspect the contents of the person variable by typing person semicolon. It returns John as the result. Now that I have this value in a variable, I no longer have to type John every time I want to use it. I can have JavaScript output the text, hello John, to the console by using the built-in console.log method. This is a common approach to outputting values in JavaScript. Notice that the browser is intelligently trying to guess what programming statement I want as I type. Don't worry about this now. I just want you to concentrate on variables and the console.log method. The console.log method can accept one or more values, separated by commas. So I type console.log, open parenthesis. Then I type hello in quotes, comma, person for the variable, and then close parenthesis. Notice that hello John is now logged to the console. This is an example of combining static text with a dynamic variable where the value can change. But why stop here? Why not save the greeting in a variable too? Let's create another variable and call it greeting, and assign this new variable the value hello in quotation marks. Now, when I use the console.log method with both variables, greeting and person, the words or the values of these variables, hello John, are logged to the console. Finally, let me show you why variables are so useful. Now that I have the person and the greeting variables, I can reassign them, replacing their stored values. For example, I can change the value of the variable from hello to hi by typing greeting equals hi in quotation marks. Similarly, I can change the value of the variable person from John to James by doing the same thing. I type person for the variable, then equals, and finally James in quotation marks. Now the value of the variable greeting is hi, and the value of the variable person is James. Notice that now I haven't used the var keyword when I reassigned the values to the variables that I created earlier. That's because JavaScript already knows that these variables exist in the world that I'm building. But the variables don't have to be static and unchangeable. That would be a pretty boring world, right? Now, I run the exact same piece of code as before by typing console.log and the name of the variables. Notice that I'll get a completely different result logged to the console, hi James. This is very important because it allows me to use the same code and get different results. This is the power of variables. If you want to find out more, there is an additional reading at the end of this lesson. Congratulations! You now know how to create a variable in JavaScript. Variables allow us to make the exact same code produce different results, making our programs versatile. And that's it for this video on variables. Now that you've had some insight into how JavaScript's world building works, I hope you are excited to learn about more than just variables. Imagine for a moment that you are faced with the task of moving all your belongings to a new place. What steps would you take to make the process more efficient? Well, you'd probably start by sorting items and packing them into boxes, and then labeling those boxes so that you have an idea of what each one contains. After moving them, you put each box in the room it belongs, to make unpacking quicker and easier. You can also think of programming in a similar way to packing and moving boxes. You have many different data types at your disposal, but coding efficiently starts with knowing when and where to use them. In this video, you'll learn to identify the primitive data types in JavaScript, You will learn about their specific use cases and when to use each data type. There are 7 primitive data types in JavaScript. These are string, number, Boolean, null, undefined, big int, and symbol. Let's begin by learning about the first 2, which are strings and numbers. Let's say that you are building an e-commerce app for selling guitars. When a user views the page for the most popular model, you want them to see the name of the guitar, the description, the best guitar around, and the price of $375. Seems simple enough, right? But how can you ensure that the information displayed on screen is stored effectively so that the app can use it? You would do this by using the most appropriate data types. But what does data mean exactly? Well, each piece of information in your app has a different value, and all values are collectively referred to as data. But the values differ and therefore need to be stored differently. For example, you store the name and description as text values, and the price as a numerical value. In JavaScript, text values are known as the string data type, while numerical values are referred to as the number data type. From a programming perspective, making a distinction between numbers and text is important because they adhere to different rules. For example, to build a number, you simply type in the numerical values, but to build a string in JavaScript, the characters must be enclosed in either single or double quotes. There is also a difference in the number of combinations that the number and string data types can store. The number data type has a very wide range in JS, enough for most common use cases. However, it is limited up to a point, determined by JavaScript's calculation capabilities. The string data type practically has an unlimited number of combinations of characters. There is almost an infinite number of ways we can combine different characters into strings. Okay, so back to our app example. The data must be stored using different types. The price will be stored as a number, while the name and description will be stored as strings, with each one wrapped in double quotes. You now know that the string data type is great for storing values such as titles and descriptions, while the number data type is better suited for prices or any value that you would like to calculate. However, there are additional data types in JavaScript to help you tackle different tasks. Next, let's explore each of the remaining data types and their specific use cases to better understand how you might make good use of them. Let's think of each one as a box, like I mentioned earlier. The Boolean data type has only 2 values, true and false. This means that it is useful for making decisions. Sometimes it's necessary to know when a variable does not contain a value, and JavaScript has 2 data types to express just that. First, there is the null data type, which only has the value null and represents the absence of value. You also have the undefined data type, which can only hold the value undefined and usually refers to a variable that has not yet been assigned a value. The capabilities of JavaScript have evolved over time, and version ES6 introduced 2 new primitive data types to help with more complex tasks. One is the big int data type, which is like an extra large box that can accommodate a much greater range of numbers than the number data type. Finally, there is the symbol data type, which can be used as a unique identifier. Think of it as having multiple boxes with the same label and using different serial numbers to avoid mixing them up. In this video, you've learned about the various data types available in JavaScript. Remember that every data type has a specific use case, and knowing when to apply each one will make you a better coder. See you next time. Where do you think the name operators come from? Does it have something to do with an operation of some sort? Well, the answer is yes. Operators are used to perform operations on variables and values. An operator is used to manipulate individual data items and return a result. For example, you may already be familiar with the assignment operator to assign a value to a variable. You use assignment operators for simple and complex calculations. They provide us with similar options to those on a calculator. In this video, you will learn about assignment and logical operators and how to use them in JavaScript. First, let's start with the assignment operators which you can use to perform simple arithmetic. For example, to add two numbers, you can use the addition operator, which is represented by the plus symbol. If you want to subtract values, use the minus operator, which is represented by the hyphen symbol. If you want to perform division, for example, 35 divided by 5, use the division operator, which is represented by the /. Finally, to multiply numbers, use the multiplication operator, which is represented by the star symbol. In addition to assignment operators, you can also use comparison operators, which compares and returns a logical value based on whether the comparison is true. For example, you can compare numbers to check if they are greater than, less than, equal, or not equal to each other. You will learn more about the various assignment and comparison operators later in this course. But for now, let me tell you about logical operators. Logical operators are used in JavaScript to determine if something is true or false. For example, the logical operator named AND, which you can use to check that two or more conditions are true. Imagine you had a variable named a, and you wanted to check that its value is greater than 5 and less than 10. For this to be satisfied, both statements must be true. Alternatively, there is the operator named OR, which checks for at least one of the statements to be true. For example, A is greater than 5, or A is greater than 10. Finally, you can use the logical operator NOT, which returns a false value if the result is true. Operators are used to control the flow of a program that meets certain criteria. Now let me demonstrate how to use JavaScript math and logical operators. Okay, so I've opened VS Code here, and now let me demonstrate how you can use arithmetic and comparison operators in JavaScript. Recall that comments are used to specify which lines JavaScript should ignore. As you learned earlier, you can put almost anything inside comments. Notice I have two multi-line comments. The first one lists some arithmetic operators, and the second one lists some comparison operators. I also have several single-line comments. You already learned that JavaScript completely ignores comments, and here's the proof. I click on the Run Code icon. Notice that the output in the right panel will not show any values other than the expected additional info on the code that was run. Let me clear that for now and show you how to work with some arithmetic and comparison operators. I'm going to uncomment all single-line comments from lines 14 to 21, so that you can focus on each of these console logs separately. This will then allow me to demonstrate how each of these operators behaves. So let me delete the two // on line 14 and rerun this file. Notice I get the value of 4 outputted to the console, resulting from adding the values 2 plus 2. Okay, let me clear the console, comment line 14 and uncomment line 15. This is an example of adding multiple numbers using the plus operator. Notice when I run this, I get the output of 15. Let's do another one using the subtraction operator to subtract 18 from 20. If I run this, I get the expected output of 2. Next is multiplication, which is represented by the asterisk symbol. Here I will console.log the values of 2 times 3 to get the value of 6. On line 18, I use the / symbol for the division of 8 by 1. And notice when I run this, a value of 8 is outputted. Success! And that's it for performing simple arithmetic in JavaScript. Okay, let me clear my screen again. Now I want to demonstrate how to work with comparison operators. Notice on line 19, I use the greater than symbol to check if 3 is greater than 2. Run it, and indeed it is. I get an output of true. On line 20, I use the greater than symbol to check if 2 is greater than 3. and since it's not, I receive an output of false. These words true and false are special kinds of values used in JavaScript. Don't worry too much about them now, as you will learn more about this later. For now, I just want you to focus on the final line of code. This checks if one value is equal to another value. It's important to remember that you need to use the equal symbol twice for this comparison operator to be valid. This is because the single equal symbol is used for the assignment operator, like when you assign a value to a variable. Okay, so I would expect the value of 10 to be equal to 10, so let's run it to find out. And it is. Notice a value of true is outputted to the console. Congratulations! You have now learned how to work with operators in JavaScript. This is a must-have skill in your development toolkit, as they are used in many areas of programming. Great work!
In JavaScript, like in other programming languages, there are different data types. The number data type is the foundational part of JavaScript as a programming language because it represents both integer and decimal point numbers. Without it, you wouldn't be able to code. And with such a crucial data type, we better get started right away. So let me demonstrate the number data type. I type the value 123 into the console and press enter. Notice that the output is 123. Next, on a new line, I type a decimal value 123.456, which is also a number data type. I press the enter key again and get the decimal value 123.456. In JavaScript, we can use numbers to perform math operations. For example, I can code 2 plus 2 and get the value of 4 returned. Just like in regular mathematics, we use the plus symbol for addition. Similarly, use the minus symbol to perform subtraction. For example, 4 minus 2 returns the value of 2. For multiplication, use the asterisk or star key. So, 4 times 4 will return 16. For division, use the / key. 16 divided by 4 returns the value of 4. You can use a double star sign to perform exponential calculations for slightly more complex arithmetic. For example, 10 to the power of 2, 10 times 10, will return 100. A final example is the remainder or the modulus operator. This checks how many times you can fit one number into the other and then returns the remainder. So if I type 9 modulus 8, the value of 1 is returned. Or 16 modulus 8 returns a 0. This is because the number 8 divides into the number 16 evenly. There is no remainder as represented here by the 0. Besides basic mathematical operations, you can also use parentheses to group more complex calculations. For example, 2 times 4 plus 8 can return a different answer depending on the order used for calculation. For example, multiplying 2 times 4 and then adding the value of 8 returns 16. But 2 times the value of 4 plus 8 returns 24. By using parentheses, I can control the order of calculations. Without parentheses, JavaScript will follow the standard mathematical sequence of calculation. In this case, the multiplication would take precedence and be done first. So the 2 times 4 happens first, and then the 8 is added, returning a value of 16. Remember, I can override that using parentheses and get a different result. That's an example of using parentheses in JavaScript with numbers and mathematical operators. Some of the most common JavaScript mathematical operators are plus, minus, times, division, and modulus. If you would like to learn more about mathematical operators, there is an additional reading at the end of this lesson. Since you're new to JavaScript, you might not be familiar with strings. Strings are used to represent and work with a sequence of characters while programming in JavaScript. Let me explain how they work. To demonstrate the concept of strings, I have the developer tools open in my browser and the console tab is selected. So what is a string? A string in JavaScript is a collection of characters enclosed by single quotes, double quotes. Such a collection of characters is known as a string data type. Strings are one of the most common types of data you'll be working with. To code a string, I type in a pair of single quotation marks. This piece of code with just an opening and closing single quote is referred to as an empty string. To build an empty string, I can also use double quotation marks. While empty strings have their place in JavaScript, they're not very versatile. But strings don't have to be empty. So let me build a non-empty string with some letters and an exclamation mark. I do this by typing the words, "hello there," and an exclamation mark within a pair of single quotation marks. Besides letters and punctuation symbols, we can add almost any other character into a string, including numbers. For example, I can type "hello there" and follow it up with several symbols and numbers. This is still a valid string. There's one thing that strings can't do, and that is break onto the next line. When I type a single quotation mark, the word "hello," and then press enter before typing the second quotation mark, it results in an error which stops the code from running. The same happens if I use double quotation marks. When you use single or double quotes to surround string values, these characters are referred to as delimiters. This is because I use them to delimit a given string value from the rest of my code. There are some unusual situations that can trip you up when you first start using strings in JavaScript. For example, let's say that I want to create a new string. I do this by typing a single quotation mark, followed by the phrase, "It is a lovely day," and I close the string with a second single quotation mark. Now I want to use the contraction of "it is" by using an apostrophe, but I get an error code. This is because JavaScript reads the word "it," that is, the first two letters, as forming a string, and then it doesn't understand the rest of the code because of the apostrophe. To fix this issue, I need to nest single quotes inside double quotes. I do this by replacing the original single quotation marks on either side of the phrase with double quotation marks. And now you'll notice there are no more errors. You can mix single and double quotes too, but it's better to stick with one or the other because it can be confusing and lacks consistency. And there you have it. You have learned what a string data type is and what an empty string is. You can also explain what the string data type is in JavaScript. I encourage you to try and make some more strings while practicing coding. The Boolean data type is used to check if a statement is true or false, which makes it a foundational part of knowing how to use JavaScript. It has many uses, but in this video, I will focus on how to get the result of a comparison to determine if two values are the same or not. What is a Boolean data type? To understand the answer to this question, let's think about a real-life scenario of comparing numbers, such as, for example, checking if number 1 is smaller than number 2. In JavaScript, I do it like this: 1 less than sign 2. When I press the Enter key, JavaScript says that this is a true claim. Let's do some other comparisons. Let's check if 1 is greater than 2. 1 greater than sign 2. This code returns the value of false of the Boolean data type. No matter how I compare numbers, the result of the comparison will always be either true or false. There are no maybes here. That's why the Boolean data type has only two possible values, true and false. Besides the less than and the greater than operator, I can also use some other operators to compare numbers. It might help to think of these various comparison operators as tests. Let's say I want to test if the comparison of two numbers is correct or incorrect. Now I will run a few tests with some additional operators, starting with checking for equality. 1 equals 2. I'm claiming that 1 is equal to 2, and JavaScript returns false. No, 1 is not equal to 2. My claim is false. When first introduced to the syntax, with two consecutive equal signs, it is not uncommon for people to be slightly confused. Why the double equal sign? After all, you know that in mathematics you only need a single equal sign to signal equality. But in JavaScript, I use a single equal sign as the assignment operator to assign a value from the right side of the assignment operator to the variable on the left side of the assignment operator. For example, I can type var score equals 100 to declare a variable called score and assign it to the value 100. In other words, I can now confirm that the value of score is 100 by typing out score in the console. Indeed, 100 it is. In contrast, in JavaScript, the equality operator has two equal signs, and it checks only for value. Additionally, there's also the strict equality operator that has three equal signs, and it checks for both the value and type. For example, if I use the equality operator, let me type 100 double equal sign, double quotation, number 100, and close double quotation, the console will return the Boolean value of true. By using the double equal signs, I compare only the value and not the type. JavaScript checks only if 100 is equal to 100, regardless of the data type. It ignores the fact that the 100 on the left of the equality operator, without the double quotes, is a number, and that the 100 on the right of the equality operator, with the double quotes, is a string. The strict equality operator is more unforgiving. It checks for both the equality of value and the equality of type. Therefore, comparing the number 100 without quotes with the string 100 with double quotes will return a Boolean value of false. Why is this false? It is false because although the value is the same, the type is not. The number 100 does not have the same type as the string 100. There's also an operator that's the opposite of the equality operator, the inequality operator. It's a combination of an exclamation mark and an equal sign. Let's test it. I type number 1, exclamation mark, the equal sign, and number 1 again. It returns the Boolean value of false because it is false to say that 1 is not equal to 1. Additionally, just like there's the strict equality operator, there's also its opposite in the form of the strict inequality operator. This operator is an exclamation mark with two equal signs. Let's type number 1 as a number, exclamation mark, the equal sign twice, and then number 1 inside double quotes, that is, as a string. This returns a Boolean value of true because the number 1 is not the same as a string 1 by both the value and the type. So it's true that these two values are not the same. There are other kinds of operators in JavaScript, and there are some additional concepts like operator precedence and operator associativity, but we'll skip these for now. With the examples covered in this video, you should have a basic grasp of how the Boolean data type works and what it's useful for. You will encounter Boolean values again because there are other important ways in which you can use them in your code besides comparing numbers and strings.
Every day, from the moment we wake up, you and I make decisions. From what clothes to wear, whether to have tea or coffee for breakfast, or even what movie to watch. While some decisions are complex, some can be relatively simple, and we make them based on whether some condition is either true or false. For example, if it's raining outside, we will likely bring an umbrella. The condition here is the weather. If it's raining, we take an umbrella. If it's not, we don't. In this video, you will learn about conditional statements in JavaScript using the if and else statements. In JavaScript, there are pieces of code called conditionals, and developers can use them to run code conditionally, based on whether something is either true or false. There are many types of conditional statements, but the first one I want you to learn about is something called the if statement. The if statement checks a condition and will execute a code block if the condition is met or true. The condition criteria are essential here. The block of code will only get executed if the condition is evaluated to the Boolean value of true. You can use many types of comparison operators to evaluate the condition. These include operators such as equal to, greater than, less than, and not equal to. You can find a complete list of comparison operators from the additional reading at the end of this lesson. So far, you've learned about using conditionals with binary conditions where a thing can be either true or false. However, in the world of programming, things are often not that simple. Imagine you are a developer working on a website where a person can practice for their driving test. Part of the driving test is that they must pass a theory exam of 50 questions based on the rules of the road. The exam has only two results, pass or fail. If the student scores greater than 40, they pass. If not, they fail. You need to output the exam result to the learner. This is where another conditional statement can be used, and it's called the if-else statement. This statement handles both outcomes of our conditional request using the else keyword. If a condition is true, do something. If it's false, do something else. Recall our driving test example. We can store the test result in a variable. Suppose the variable value is greater than 40. In that case, the true block is executed, and you output a message to the console telling the learner that they passed. Suppose the variable value is less than 40. In that case, the false block is executed, and you output a message to the console telling the learner that they did not pass. There will be many occasions where you will need to program for more complicated conditions or scenarios. For example, you may want to test multiple conditions. To do that, you can add an additional block called the else-if statement. In this video, you learned about the conditional statements, if and else. Conditional statements are a powerful tool and one of the fundamentals you need to master when programming in JavaScript. Recall that conditional statements are used to run pieces of code based on whether the condition is either true or false. Okay, let me demonstrate this now with a simple example using a variable and an if-else statement. Additionally, we'll learn how to deal with cases where we have multiple if-else-if conditions. For example, the if-else statement can be used when you want to execute code based on a certain condition being either true or false. But what if you have 5 conditions or even 10? Well, you could use multiple lines of else-if. There is another way to do this, using something called a switch statement. Okay, let me demonstrate this now with an example of when to use else-if and when to use the switch statement. So I have VS Code open here, and notice that I have pasted in an example of an if-else statement. First, on line 3 here, I've assigned the value of 50 to the variable result. Then, on line 5, I'm checking if the result is greater than 40. If this returns the Boolean value of true, my code will console log the words, "You passed the test." After that, on line 7, I specify the else block, which will run when the if condition returns false instead of true. In that case, I use console.log to output, "You did not pass the test." Okay, so now let's run this code. And, as expected, I get the output of "You passed the test." This happened because the statement 50 is greater than 40 in the if condition returned true, and its associated block of code was executed. Now, let me change the value of the result variable to, say, 30, and rerun the code. This time I was notified that I did not pass the test. This was because the condition 30 is greater than 40 was evaluated and returned false. The code was skipped inside the if block. Instead, the code inside the else block was run. My code works well because I'm checking a binary condition here, but what if there are more options? In that case, I'll need to cover all these possibilities. Let me switch tabs to demonstrate this using else-if statements. Okay, so notice that I have a variable named place, and it's assigned to a string with the value of first. Next, notice my code contains 4 conditional statements. The first is an if statement that checks if the value of the variable place equals the string value of first. If this is true, then a message of gold will output to the console. As there are 3 more conditions, the next one needs to use an else-if block. This time, I'm checking if the value stored in the place variable equals the string value of second. Once again, if this is true, a message of silver will output to the console. Notice lines 9 and 10. This code is another else-if block that checks for a value of third and outputs the message of bronze. And this process would keep repeating for as many conditions as needed. Finally, if no condition is met, I have a catch-all else statement at the end. This is crucial because if the conditional checks for the values first, second, or third are not satisfied, the else block will run and output the text "no metal." Okay, so this code looks good to me. Let me run it to test the output. Notice the word gold is outputted. While this method is correct, it can become a bit unmanageable when there are multiple conditions. For example, say you had to evaluate 10 conditions. Luckily, there is another statement at our disposal, and this is called the switch statement. Let me switch tabs again, and now notice the code. So here I have a switch example, but I want to examine these files side by side. So let me click on the tab of the switch statement file, and I'll drag it around until I find a good place for it. That will allow me to compare the code. Let's adjust this a little bit more and clear the output of the console. OK, so you may notice that the syntax is significantly different by inspecting these two files. If I run the switch statement code here, I get the same result. The word gold is output. Also, if I change the value of place variable to say 4th, the default case will be run, and the text no middle will output to the console. The if-else example code acts precisely the same, so here when I update the variable place to 4th, the same thing happens. The words no middle are logged. Congratulations! You have now learned about conditional statements using the if and else. You've also learned how to streamline multiple conditions using the switch statement. If you would like to learn more about conditional statements and operators, there is a link to an additional reading at the end of this lesson. In our everyday life, there are times when we have to repeat some activity again and again. For example, closing each button when putting on a shirt, washing a stack of plates one by one, or counting down from 10 to 1 before singing Happy New Year. Repetitive tasks are a fact of life, and sometimes we also need to do these in our JavaScript code. In this video, you will learn about looping constructs and how they can be used to perform repetitive tasks. Recall the conditional if statement that executes a block of code if a certain condition is met. This sequence only runs once. What if you needed to do this multiple times? Well, to do this, you need to do something called loops. In JavaScript, developers use loops to continually execute repeated blocks of code until a certain condition is satisfied. Loops are similar to conditionals in that a condition must be satisfied in order for the code to execute. But loops have an additional parameter, which has many names. But for the moment, you can think of this as an incrementer or loop counter. To understand why the counter variable is so important, let's consider a real-life situation. We are counting down from 10 to 1 before singing Happy New Year. In other words, only after we have completed the count, we can start singing. Thus, our counter needs to be a specific value, a 1, and only after that we can sing our song. In JavaScript, the counter can be any variable or any number, but in programming, it's common to use the letter I. The role of the counter is vital here, as without it, your loop will not know neither when to start nor when to terminate and could run indefinitely. This is known as an infinite loop. For example, say you wanted to program a count sequence like 1, 2, 3. You could do this just by using the console.log method. However, we are essentially performing the same activity here. The only difference is that we are changing the number that is being logged to the console. Using a loop, we could perform this same task more efficiently and using less lines of code. While this might seem like a minimal gain for counting to 3, imagine counting to 100. Using a loop, you can achieve this with the exact same 3 lines of code. You just have to update the condition. There are many types of loops, such as the for loop, the while loop, and the nested loop. You will learn about the nested loops later in this lesson. For now, let's explore the for and while loop. First is the for loop, which is used to loop a block of code a certain number of times. The for loop is a structured loop with a specific conditional structure where a counter variable must be set. Then a condition must be specified, and finally the counter must be incremented. This can either be an increase or a decrease depending on your needs. The while loop is similar to the for loop. It will also run for as long as the condition returns true. However, the start counter is set outside of the while loop, and the incrementing is done inside the loop's body. Congratulations! In this video, you learned about loop construction using the for and while loop. While you can achieve the same results using either a for or while loop as a budding developer, you might find it easier to work with the for loop. This is because the loop is self-contained, with all the loop's logic in one place. Additionally, always remember to update the counter value, otherwise the loop might loop forever.
Let's say you want to code a count from 1 to 3 and then say go, as if we are racing. You could do this by logging each step to the console for 1, 2, 3, and go. While this method works, imagine a situation where you have to count from 1 to 10, 1 to 100, or even more. Would we have to type the console.log method 100 times? Luckily, there's a more efficient way to do this by using something called a for loop. Okay, so let me just clear my console and paste in an example of how to do this using a for loop. First is the declaration using the for keyword. This declaration consists of something known as the counter. The counter is a variable which is typically named I for iterator, but you could use any variable name you want. The counter has 3 conditions for the for loop to function. First, the start count value must be assigned. In this example, it's 1. The second condition is the end count value, and this specifies how many times the loop will iterate or run. In this example, the condition is that the value of I must be less than or equal to 3 for the loop to run. The final part is the incrementer, which changes the value of I on each loop. It's set to increase the number stored in the variable I by 1 each time the code inside the loop runs. You may have learned the technique I equal to I plus 1, but you can also use the syntax I plus plus as another way to increase the value of I by 1. If you do not specify how the value of I should be increased after each loop, the for loop will run forever, as I would always be less than 3. So you need something known as an exit condition. The exit condition works with the incrementer to prevent the loop from running forever by specifying at which value to terminate the loop. In this example, the loop terminates when the value of I is greater than 3. So the loop will terminate when the exit condition returns false. In other words, until the value of I equals 4. And since 4 less than or greater than 3 returns false, the for loop will exit and JavaScript will continue reading and running code below it. The final part of the for loop is the loop body, which is enclosed in curly braces. This contains the block of code that I want to run on each loop iteration. In this example, I want to print the value of I to the console using console.log method. Notice that this code outputs the same result as displayed earlier. Let's see it in action. Great, you've just created your first for loop. There are different ways that you can work with for loops. For example, I could start my count at 10 and set the value of I to be greater than 0. Now, instead of incrementing the value of I with plus plus, I can decrement with the value minus minus. This is essentially like counting backward. And instead of saying go, we might say Happy New Year. I press enter and notice the result. The countdown outputs from 10 to 1, and the greeting Happy New Year is displayed. Let's break down what's happening here. The console.log part of the for loop was repeated 10 times until the value of I reached 0. Once the value of I reached 0, the condition I greater than 0 was no longer met and the loop exited. Remember, a for loop is a way to automate repetition in JavaScript. Why not try creating one in your own code to repeat some code? In this video, you will learn about another type of loop, the while loop, and use it to code a countdown to the Happy New Year greeting. The while loop is quite similar to the for loop, but they're not exactly the same. The first major difference is the counter value. With a while loop, this is set before the loop and must be clearly defined. Let me demonstrate this now. First, I create a variable called counter and set its value to 3. Next, I want you to know about the second major difference. This is that you only need to specify the exit condition in the parentheses of the loop declaration. Or, put differently, we just give JavaScript an expression to check. If that expression returns true, JavaScript will then run the code inside the while loop. In this example, our condition will be counter is greater than 0. Since the counter value of 3 is greater than 0, it returns true. So to construct the while loop, I type the word while and then the condition inside the parentheses. This is counter greater than 0. Next, inside the while loop's code block, I need to tell it what to do. In this example, I want to run the console.log method to output the value of the counter. Then I need to decrement my counter by a value of 1. This means that the first time JavaScript starts running the line of code with the while loop declaration, it checks the value of the counter variable. If the counter value is greater than 0, and it is, it will run the code inside the while loop. Then, it will output the current value of the counter variable to the console, which is the number 3. Next, it will calculate the value of counter minus 1, that is, 3 minus 1, which is 2. It will then update the counter variable by assigning the number 2 as its new value. Finally, it will return to the while's condition and check if the counter value is greater than 0. That is, if 2 is greater than 0. Since it is, it will go into the while loop's code block again and output the counter's current value, which is 2. Then it will update it again by assigning the result of 2 minus 1 as the updated value of the counter variable. Now, since it's reached the end of the block, JavaScript will go back up and confirm that it's true that 1 is greater than 0. Then go inside the while loop's body again, output the value of 1, and update the counter to 1 minus 1. Since it's reached the end of the loop's body, it will go back up and check if 0 is greater than 0, and since it isn't, it will not run the code inside the while loop again. Instead, any code under the closing curly brace of the while loop will run. To demonstrate this, I add another line of code under this closing curly brace and console log the string Happy New Year. And that's it! Congratulations, you have now learned how to create and run a while loop. Why don't you give it a try? Loops are a common way to automate code repetition. If you would like to learn more about the specific use of loops, there is an additional reading at the end of this lesson.
What if you need your code to perform more than one task at the same time? Maybe you need to process dataset A, but at the same time also process dataset B. In cases like this, you can use nested loops. You might already be familiar with the for loop, which is used for instructing your code to perform the same task over and over again. But with JavaScript, it's possible to nest loops within other loops, so that multiple tasks can be performed at once. And there can be multiple levels of nesting too. Let's now examine a practical example where you might use a nested loop. Suppose you are creating a 2-week plan for the days Monday to Friday. You need to output each day number and the week it's associated to. So, you have 5 days for week 1 and 5 days for week 2. Using a nested loop is the perfect way to achieve this output. Let me break it down for you now, using an example with for loops. If we recall our example, we have 2 categories, weeks and days. The first loop, also known as the outer loop, will loop over the weeks. So, an increment counter of 2 is required, and this is created with a variable named I. Then the nested loop will loop over the days. To do this, another increment counter is required, and this is created with a variable named j. Finally, the console log method is required to output the text with the values of I and j to the console. This code outputs 10 lines, week 1 and each day from 1 to 5, and then the same for week 2. However, you need to take care not to overdo it, as multiple levels of nested loops are not very performant. In other words, the more nested loops there are, the slower your code will run. Let's now explore an example where you will output code using nested loops to display the summer months over 2 years. Okay, so I'm back in my browser's console, and I start by pasting in a for loop declaration. Notice this specifies the year variable as 2023, and the exit condition when the comparison of year is less than 2025 returns false. I've also set the year's value to increase by 1 on each loop. Essentially, I've coded this loop twice. Next, I type console.log in the loop body and place the variable year inside the parenthesis. Okay, so I expect the output to display 2023 and 2024. I run the for loop to confirm that this is the case. And indeed, the values 2023 and 2024 are logged to the console. And this is a process that you are already familiar with. Now I want to demonstrate a nested loop, and to do that, I need to add another loop inside the body of the first for loop. This will also be a for loop. This time I type for var month equals 6, month less than 9, and month plus plus. What I'm doing here is counting only the summer months. The summer months are usually June, July, and August in the Northern Hemisphere. So that's month 6, 7, and 8. Notice that the counter will start at month 6 and it will keep checking if the numbers stored in the month variable are less than 9. On each subsequent loop, the value stored in the month variable will increase by 1. Effectively, it's going to go through month 6, 7, and 8, and after it runs these 3 loops, it's going to stop. So now I type console.log in the body of the inner loop. And to make sure that I showed that this is nested, I'm going to add several dash characters, and then the month variable. And now, when I run this code, the outer loop will run for the first time, and it will set the value of the year variable to 2023. Then console log that number, and then go into the code of the inner loop and run it. Once inside the code of the inner loop, I can expect the code to run 3 times and output -6, -7, and -8. The inner loop will then exit, and the code will move back to the outer loop to begin the next loop cycle. When this starts, the value of the year variable has been increased by 1 to 2024. This still satisfies the condition of year is less than 2025. So the code logs the year and proceeds to the inner loop. JavaScript will go into the inner for loop again and rerun it. Once again, it will output 6, 7, and 8 again. And this code will continue this sequence displaying the year 2024 and the final 3 months of summer. Let me run the code now. And success! The code produced my predicted output. Okay, before I end this video, let me demonstrate how to simplify the for loop. Instead of using these long variable names, I can just use I instead of year, and I can use J instead of the month. This makes the code easier to read. It might seem harder to understand because I'm using I and J instead of more descriptive names. But these variable names are standard practice in the development community and are considered a best practice to use. You have now learned about nested loops and the reason to use them. It's important to remember that while nested loops are an option for developers, they can be resource intensive. Nested loops can be used in instances where you need automated repetition of code. For example, sorting numbers from highest to lowest. A good developer writes code efficiently to maximize resources, and you are on your way to becoming one of them. You've reached the final video in this lesson on conditionals and loops, and the end of the introduction to JavaScript module. Let's take a few moments to recap on what you've learned. In this module, you have learned how to explain what programming is and the role it plays in the modern world, describe what JavaScript is and its value as a web development tool, describe how developers interact with the JavaScript engine to create web experiences, create variables and assign or reassign the values they contain, identify the 7 primitive data types in JavaScript and how they differ from one another, explain what strings are and the syntax for building them, identify the values of the Boolean data type, and explain what you can and cannot do with the numbers data type. Build if-else statements to create conditional outcomes, and build for loops to repeat repetitive tasks. Congratulations, you have now completed this module. Great work.
Thanks you for watching my video, please. Like and subscribe my channel. Thank you for spending your valuable time with us. Your views and support mean the world to us. We couldn't do it without you. Thank you for being a loyal viewer.
Have you ever wondered how, when you turn on the dial or press a different button on your washing machine for a specific wash, it just knows what to do? You select Sports Wash and the machine runs a wash cycle at the same temperature every time. Or you turn the dial to Synthetics and the machine runs a wash for the exact same length of time each time. Functions work just like this. running the same set of stored instructions repeatedly without requiring you to adjust the settings every time. Over the next few minutes, you'll learn about the advantages of using functions in JavaScript. You will learn how functions are structured and how to declare a function in your code with the use of parameters. Finally, you will discover how to call or invoke a function with your code with the use of arguments. But first, what is a function and what does it do? One of the basic principles of programming can be summed with the acronym DRY. In other words, don't repeat yourself, and it's thanks to functions that you can avoid repetition. With functions, you can take several lines of code that perform a set of related actions and then group them together under a single label. Then, when you need to run the code that you've saved, you just invoke or call the function. You can run the code as many times as you want. For example, suppose you want to add two numbers. The process could be as follows. First, create two variables, a and b, and assign each a number value. Then create another variable, c, which holds the value of a and b added together. Finally, output the value of c to the console. This piece of code works and adds two numbers together. But what if you want to execute this code more than once? Well, you can do this by placing this block of code inside a function. You declare a function by typing the keyword function, then space, and then the name of the function. You can name the function nearly anything you want. In this example, it's named add2nums. After the function name, place a left and right parenthesis. Finally, place a left and a right curly brace to complete the function. The code to be executed will then be placed in between the left and right curly braces, and this is known as the body of the function. It's important to remember that a function declaration on its own doesn't execute the code. It's just specifying what operations should be performed once the function is executed. To run the function's code, you need to call or invoke the function, and this is achieved by typing the function named, followed by the opening and closing parenthesis. Instead of saying run a function, developers may say that they call a function or invoke a function. But don't worry, all these terms mean the same thing: to execute the code inside the function's body. Next, let's explore another major advantage of functions: the use of values. Did you notice how the add2nums example was just adding the numbers 10 and 20? These numbers are our chosen values for this function. But this is just one example of the use of values. With functions, you can use any values you want. Take, for example, the add2nums function created earlier. The function accepted no arguments. In other words, no parameters were defined. While variables can be used to produce results, there are limitations. As variables, a and b have specific values, and the function would always give the same result. So, let's change this function to make it more flexible. To do this, you need to pass values to the function. These values are known as function parameters and are placed inside the function definition. The values passed to the function are called arguments. Let's explore this a little further now. By setting a and b as parameters instead of using variables, I can easily plug in any two numbers that I want to add. Parameters are sort of like variable names. They allow us to set changeable values on each function call. Functions with parameters can accept any kind of value and result in clean, more efficient code. Building functions this way allows you to write flexible functions that can be reused with various values as many times as you need. For example, by passing values as arguments to our function add2nums, we can call it as many times as we want. And as long as we send it two values, it will add them together and output the result. In this lesson, you learned about functions in JavaScript. First, you created a function without parameters and assigned fixed values inside the body of the function itself. Then, you learned about function parameters to pass values to functions. It's important to remember that function parameters act sort of like variable names. The actual values that these variables will be assigned will come in the form of function arguments at the time the function is invoked. You're now familiar with the advantages of using functions, declaring a function with parameters, and calling a function with arguments. Working with functions is common in day-to-day development and is one of the core skills a developer needs to master as they help you write more efficient, reusable code. You probably know that freight trains are an important means for moving cargo. But have you ever thought about the system that keeps things running smoothly as changes are made at every stop? Carriages are typically set in a specific sequence, and each carriage may carry different items or materials. Other carriages can also be added or removed without disrupting the rest of the order. Much like a freight train, JavaScript has a piece of functionality that allows you to store and rearrange sequenced collections of items. This is called an array. In this video, I'll guide you through how to build an array and access its contents. I'll also demonstrate how JavaScript stores the contents of the array and indexes its values. Let's say that you want to emulate a toy freight train using JavaScript. On this train, each carriage has a number painted on its side and is presented in sequence, starting from 0. Using JavaScript, you'll assign some cargo to each carriage. For the first one, let's input var carriage 0 equals wheat. Great. Now when you inspect the contents of carriage 0, you'll get back the word wheat. You can use the same approach to model your entire train. Let's say you do just that and end up with 5 variables of different values. You've just built a train with 5 carriages, each holding different cargo. Now let's make things interesting and introduce a second train. This one only has 2 carriages, with the number 0 and 1 painted on the sides. Seems pretty simple, right? Well, you can't use the variable names carriage 0 and carriage 1 because they're already taken. You could use more descriptive names such as train 2 carriage 0 and train 2 carriage 1, but that feels a bit wordy. Another problem is that you need to signal that these variables are a collection belonging to train 2. But when written this way, JavaScript doesn't understand that. Luckily, we can fix this. To make JavaScript understand that we will group a sequence of variables in a collection, we use arrays. You can build an array using the array literal syntax, which is an opening square bracket followed by a closing one. The array is currently empty, but JavaScript now understands that we will provide a collection of items. So let's assign that collection to the train1 variable. Finally, let's add carriages to the train1 array by typing in the item names with each separated by a comma. So, now we have a train, but what happened to the carriage numbers? Not to worry, behind the scenes JavaScript gives each item a number, starting from 0, that corresponds to its place in the sequence. You can then use these numbers to access each carriage. For example, typing train1 followed by 0 encased in brackets will access the value inside carriage 0, which is wheat in this case. To summarize, arrays help us achieve several things in JavaScript. Arrays signal that the assigned values all belong to a group. These values are ordered in a sequence, and each one can be accessed through its index number in that sequence. In this video, you learned how to build an array in JavaScript. You also learned how JavaScript sequences array items using an index value. In programming, if you have groups of data that you would like to relate, you can assign them to something known as an object. In this video, I'll help you to understand why we use objects in JavaScript. I'll also demonstrate how to build objects using dot notation as well as by specifying comma delimited key value pairs. Let's say that you are using JavaScript to build a game, where the objective is to build your own cookie selling business. Your game is turn-based and uses tiles for characters to move, trade, and build their company. Your first task is to build a store manager character. You need to set certain traits, so let's code them with JavaScript variables. We'll set some numbers for the movement range, social skills, street smarts, and health. There, you've created a store manager, but there are a few improvements that you could make in your code. One issue is the long length of the variable names. Another is that your code does not explain to JavaScript that these variables are related and all describe the same character. This is where objects come in. Using objects, we can resolve these pain points by shortening our variable names and getting JavaScript to understand that all those variables are related. Let's start by declaring the variable store manager, to which you assign an opening and a closing curly brace. This creates an empty object literal. Next, instead of declaring individual variables for the traits, you can add a dot operator to each one, right after the words store manager. Now, when you inspect the store manager object, it recognizes these as traits of the store manager. So, here you have built a store manager object using dot notation. Each trait is a property of the object. Objects can be described as collections of related properties, where each property is represented as a key value pair. This means that what is normally a variable name becomes a property key, and what is normally a variable's value becomes the property value of the object. Objects can also be built by listing the key value pairs inside of the object literal, which specifies them as comma delimited properties. To demonstrate, let's build a new character object. First, I declare the object name using var and then the object. For example, assistant manager. Then I simply input the properties and values in between curly braces, with each property followed by a colon and its value. Next, I separate each key value pair by a comma. Lastly, I finish the declaration using a closed curly bracket. And that's it. I created an object and assigned some values to its properties. After an object is built, you can still update the object by adding new properties to it. This can also be done with dot notation. For the store manager object, you can add another property called next achievement by using dot notation. As before, you do this by placing a dot operator between the object name and the property. Then, for the assistant manager object, you can add a property with the same name using dot notation. And that's it. Now your objects have new properties added to the previous ones. In this video, you've learned why objects are valuable tools in JavaScript coding and how to build them using dot notation and by specifying comma delimited key value pairs. Perhaps you can apply this knowledge towards creating the next great game.
In this video, you'll learn how to use the random and ceil methods of the math object in JavaScript. The math object is really useful when using some of its built-in methods, one of which is the random method. For example, this method allows you to generate a decimal number between 0 and 0.99. So let's explore how the random method works in practice. One way you can work with the math.random method is to save its result in a variable. Notice I have created a variable named decimal and assigned its value to the math.random method. I can now log the value to the console, but please note the limited range of numbers that will be returned. If you want to output a number larger than 1, you must multiply the variable by 10. And I can do this with the multiplication operator using the asterisk symbol. When I click on the Run button, the output shows two numbers. The first one is a random decimal, and the second one is the decimal multiplied by 10. So this is an example of how you can extend the range of the math.random method to meet your needs. Okay, let me switch tabs now and learn about another built-in method of the math object, the ceil method. This is used to round up any decimal number to the nearest integer. Let's pass several different decimals through this method and inspect the output. Notice that I have some code pasted into this file, and on line 4, I've created a variable named rounded and assigned it to the math.ceil method. Inside the parentheses, I have placed the value 0.0001. I've logged this variable to the console. When I run my code, notice that a value of 1 is output. This is because the ceil method can only round upwards. Just to confirm that behavior, we can change the decimal. When I set it to 0.5, I get the same outcome. I change it to 0.99 and, as expected, 1 again. Okay, let's move on to working with some larger numbers. Let me uncomment line 7 and notice that 1.01 returns a value of 2. When the value is 1.5, 2 is also the output. Finally, if I run the ceil method on the value 2.99, I end up with 3. So now you understand how both the random and ceil methods work. Let me switch tabs again and next build some code that will combine the two to return a random integer between 0 and 10. The first step is to create a variable and assign it the value of the math.random method multiplied by 10. I need to pass this variable through the ceil method to ensure that an integer instead of a decimal value is created. So I declare the variable rounded and assign it the value of the math.ceil method containing the decimal variable inside the parentheses. Finally, I use the console.log method to output the variable rounded. If I run the code, notice that a value between 0 and 10 is output to the console. Just to confirm this works, I'll rerun the code and once again I get the expected result. In this video, you've learned how to use the random and ceil methods of the math object in JavaScript. Can you think of any creative uses for these? Why not give them a try in your own code?
When two JavaScript developers discuss a subject related to work, sometimes you might hear the word iterable being mentioned. But what exactly does iterable mean? Well, in JavaScript, an iterable is any data type that can be iterated over using a for-of loop. Some of the data types you can iterate over are arrays and strings. In this video, you will learn about the array characteristics of strings, and you will also explore further string manipulation using the concatenation operator. In the world of JavaScript, it can often be said that strings behave like arrays, as strings are array-like. For example, you can run a for loop over an array of letters and output the result using the console.log method. Additionally, you can also run a for loop over a string. For example, loop over the string ABC to output the letters individually. Okay, let me demonstrate this now with some code examples. In the file I have open in my console, I have a variable veggies, which has an array with 3 strings. Each string holds the name of a vegetable, specifically onion, parsley, and carrot. I've typed a console log for veggies.length, which will return the number of array items. I also have console logs for the first and second items of the array, using the indexes 0 and 1 respectively. And finally, I have an example of a for loop that sets the counter of I to 0. The exit condition for this loop is that the comparison of I is less than veggies length, returns false, and I++ is the value to increment on each loop. Inside the for loop, I'm console logging the veggies at the index of I. When I run this code, I get a 3 to represent the array length, onion from index 0, parsley from index 1, and then finally onion, parsley, and carrot as a result of the for loop outputting all the items in the array. Now, let's clear the console and move on to the next file. Here, I'll explore how strings can be iterated over. In this file, I have a variable named greeting with a string value of howdy, along with console logs for the string length and the characters at indexes 0 and 1. And again, I have a for loop that is structurally the same as the previous example. Running this code gives us 5 for the string length, H and O for the 0 and 1 indexes, and then each of the characters of the full string in sequence as an output of the loop. Despite the similar behavior, strings are not arrays. To examine this more closely, let's move on to the next example. Let me clear the output first. In this code, I have the greet variable that stores a string hello and a user variable that stores a string Lisa. Then I run a console log with the string greet and the pop method, which, as you know, removes items from an array. There are 2 other lines of code, but don't worry about them now. I cover them shortly. When I try to run this code, I get an error that says type error greet.pop is not a function. This tells me that I can't run all the array methods on strings. Now, let's run the two other lines of code. On the first one, I console log the variable greet, the plus operator, and the variable user. And on the next line, I console log the variable greet and concat method with the variable user. The concat method accepts whatever value I want to concat or join with the greet variable. In this case, both lines of code will work, so they both console log hello Lisa. So I can confirm that the plus operator here, when used on strings, acts as a concatenation operator, meaning it joins strings together. And I also have a method named concat that I can use on a string to add values to whatever string the concat method was run on.
In this video, you'll learn how to use the typeof operator to identify the data type of elements in JavaScript. The typeof operator accepts and evaluates a parameter and returns the name of the data type, represented as a string. To use it, you can type typeof followed by the parameter enclosed within parentheses. In my code, notice that I have created several instances of the variable test. Each is assigned the typeof operator with a different parameter. To check the result, I'm also using the console log method to output the value of the variable test. Okay, so as you might notice, I've commented out all the lines of code containing the test variables. To demonstrate the typeof operator using different parameters, I will uncomment each of these lines one at a time, run the code, and then inspect the output. First, I uncomment line 3, which contains the typeof operator past a parameter of a string. When I run the code, notice that the name of the data type is output, which is a string. Next, let me uncomment line 5, which contains a number value. I rerun the code and notice that the data type named number is output. If I perform these steps on a decimal number, I get the same result for the decimal number 3.14. Okay, let's now check the Boolean data types of true and false. If I run the code, the data type named Boolean is output to the console. I uncomment line 11, rerun the code, and notice that Boolean is also output. Okay, next, let me show you that you can also pass comparisons as they will evaluate to a single value, in essence, a single parameter. For example, you can pass a condition like 1 is less than 2. When I run the code, Boolean is output. You can also pass an array as a parameter to the typeof operator. However, the result might be somewhat surprising. For example, here I have an array containing the numbers 1, 2, and 3. If I run the code, the data type named object is output. This is because arrays in JavaScript are actually objects. Passing an object through the typeof operator also returns object. Finally, you can pass a function as a parameter of the typeof operator. If I uncomment line 19 and run the code, notice that the data type named function is output. Okay, and that's it for this video. You now know about the typeof operator and how it can be used in JavaScript to check the data type. I encourage you to try it out in your own practice code.
Isn't it frustrating when you're working at your computer and an error message appears on the screen and forces you to stop what you're doing? When a bug happens, our program keeps running, but it behaves in the way we didn't intend. When an error happens, our program stops running as the result of an error. In this video, you will learn about bugs and errors in JavaScript and some of the common error types, such as syntax, reference, and type errors. Suppose you have created a function that you pass two numbers. The function adds the two numbers and outputs the result. Next, you call the function and add another console log to the next line, where you will output the string still running. When you run the code, the number 3 will output. Then JavaScript will happily continue on to the next line of code and console log the string still running. This is because our example code contains no errors. When the function is called, the code is executed and then moved to the next line. While this code works as expected, what if you pass to the function some varying data types, such as a string and a number? For example, a string of 1 and number of 2. For this, recall how concatenation works. Due to JavaScript coercion, when you add a string and number using concatenation with the plus operator, the values will concatenate as strings. Thus, the result is a string of 12. Our function is now no longer adding numbers. Instead, it is concatenating strings. However, JavaScript happily continues executing the code, outputs the string of 12, and console logs the words "still running." Notice that our program is working without interruption. However, it is not working how we intended it to work. This is what's referred to as a bug, as it makes our code behave unexpectedly. But it continues to work. So, how does an error differ from a bug? Well, let's explore another scenario. Suppose you had simple programming that has two statements. The first uses console log to output C plus D, and the second one uses console log to output the statement "this line never runs." What if these two lines of code were the only lines of code in our program? Where would JavaScript find the values of the variables C and D? Well, it wouldn't, because in the sample code these variables don't exist. They have neither been declared or assigned. It would look for the variables of C and D. Since they don't exist, JavaScript outputs a reference error. This type of error occurs when a value is not defined, but you attempt to use it in your code. When an error happens, our program stops executing the code as a direct consequence. No further lines of code are executed. In JavaScript and some other programming languages, we say that an error is thrown. So, an error can be defined as a faulty piece of code that prevents the program from further execution. An error gets thrown and the program stops. JavaScript does its best with reporting error by outputting an error message to the console. This error reporting is useful because it narrows down the issue with our code. In JavaScript, there are many error types, and some of the most common are syntax error, type error, and reference error. You have just learned about reference error, so let's explore syntax error and type error briefly now. A syntax error occurs when you write a piece of code that JavaScript cannot read. For example, if you declare a variable and assign it a value of a string but forget one of the closing quotation symbols. Alternatively, suppose you try to run an array method on a number. For example, the pop method. In this example, a type error would be reported. Uncaught type error, 5.pop is not a function. You've now learned about bugs and errors and the differences between them. You've also learned about some of the common kinds of errors and how JavaScript helps you catch these by outputting error messages. It's a fact that programming errors will almost certainly occur every time you write code. Next, you'll learn about some of the different JavaScript tools used to catch these errors. Have you ever watched two people playing a game of catch? It's a pretty simple game. One player throws a ball and the other tries to catch it. You may recall that when your code contains an error, it stops running. Well, in JavaScript, there are some built-in statements to help your code continue to run even if an error occurs. They also use keywords like throw and catch. However, they try to catch the error instead of the ball. In this video, you will learn about the statements throw, try, and catch, and how they can be used to work with errors in JavaScript and prevent your code from stopping. This process is more commonly known as error handling. First, let's explore the try-catch statement that uses the keywords try and catch. If a piece of code throws an error, it can get wrapped inside a try block. Then you can catch the error with the catch block and use it to do something. For example, output the error message to the console. Another keyword that you need to be aware of is the throw keyword. Using the throw keyword, you can force an error to be thrown from the try block to the catch block. It's important to remember that you can use the throw keyword outside the try block, but it will not be possible to catch it. The catch block accepts something called an error, which is an object, This is the actual error that is thrown from the try block. While you can name it anything you like, it's best to keep it short and meaningful. In this case, I named it ERR. Let me demonstrate how this works further with some code examples. Let's define a block of code to be tested for errors using the try-catch statement. Okay, so I have Visual Studio Code open and a JavaScript file with some sample code. If I was to run this code now, it would return an error and stop working. This is because the first line uses a console log to output a plus b, but these variables are not declared anywhere. The second line has a console log to output the string "this line is never reached," and this statement looks to be error-free. When I click the Run button, a reference error is output telling me that A is not defined. The JavaScript engine then stops immediately and does not process the second line. It's not only JavaScript that throws errors in our programs. You can actually throw them on purpose. This is done by typing the keyword throw, followed by the keyword new, and then a specific errors constructor. In this case, I use the reference error constructor with a pair of parentheses at the end. When I run the code this time, I get a reference error output again. So, how can we prevent errors from stopping our programs? This is where the try-catch syntax makes itself useful. Let's go to a separate file with code that shows how that works. But first, let's break down the structure of the code. The try block starts with the try keyword, and inside of curly braces, you place the code that you think will throw an error. Next is the catch block, which catches the error that the try block produces. It begins with the catch keyword, and in parentheses, you have a built-in error object that you can name whatever you like. But here I've used ERR. Inside the curly braces, you place the code you would like to execute. In this example, the try block contains the same console log statement as before to output A plus B. The catch block contains console logs to output two strings. There was an error, and the error was saved in the error log. Finally, after the catch block, another console log outputs the string "my program does not stop." The benefit of using try-catch is that even if JavaScript throws an error while going through our code, it will not stop program execution. To demonstrate that, let's run our code example. Notice again, a reference error is output stating that A is not defined, and then the two strings from our catch block. It's important to understand here that the error is output because I logged it to the console. The string's output after the error message, proving our program continued running. Finally, let me switch tabs to another file and demonstrate how JavaScript responds when I manually throw an error. In this example, the try block contains the throw statement to throw a new reference error. In the catch block, there are two console logs. The first one outputs the error object, and the second outputs the string "there was a reference error." Outside the try-catch blocks, the program ends with a console log to output the string "my program does not stop." When I run this code, notice that the reference error is output. This is the error that was thrown in the try block and then output using the error object in the catch block. Once again, this is just the error being output. The code has not stopped running, and I can confirm this as the final console log message is output to the console. In this video, you've learned how to work with errors in JavaScript. You learned how you can use try and catch blocks and the throw keyword to deal with them. The next time you see a game of catch, think about how you can use a similar mechanism to help catch errors in your code. Imagine that a restaurant has been booked for a wedding reception and the big day has finally arrived. Unfortunately, not everything is going smoothly, and it seems that many expected guests have not yet arrived. So, how do we know that empty seats should be filled with guests? It's as simple as placing a small sign on each table. Each one tells us a person is not currently here, but a person should be here. In JavaScript, there are similar situations in which you need to mark the places where a value or object should exist. In this video, you'll learn about 3 types of empty values: the null data type, the undefined data type, and empty strings. I'll also demonstrate some of the scenarios in which you can expect to encounter these values. We'll start with the null data type. Null represents the intentional absence of any object value. It is also a return value of some built-in JavaScript methods. For example, let's say you create the variable named letters and assign it a string value of ABC. You'd like to search for the letter A in this string. You can do this by using the match method to search inside the variable. This returns an array with several pieces of information. But the most important part is that it confirms the A was found in the string. This time, let's use the same method on a different letter, the letter D. The return value of the match method should be an array, which is a kind of object in JavaScript. But since the D letter cannot be found, the array with the result can't be built. So null appears instead to indicate the absence of an object. In JavaScript, there may also be times when you are building something that hasn't been clearly defined yet, and so you can't assign a value to it. Fortunately, there is a way to store it so that you can assign it later using the undefined data type. While some data types in JavaScript can hold many possible values, others are constrained to just a few. For example, the string data type can hold a virtually infinite combination of characters, while the Boolean data type is limited to the values true or false. The undefined data type can only hold one value, undefined. You may recall seeing this in your practice code. For example, all functions return undefined by default, unless it's been decided to return a specific value instead. When you use console.log to output something like a name, you will see undefined displayed after the output. This is because console.log is a function and you are not returning a value. Another common situation where the undefined value appears is when a variable is declared without assignment. For example, suppose I create a variable named noise, but do not assign it a value. You might recall that this is valid JavaScript, and the code will run. However, as the variable has not been assigned a value, JavaScript automatically assigns the value of undefined. We can even explore this further. For example, let's say you use console.to output the unassigned variable noise. Then, on the line below, you assign the noise variable the string value of thunder. What will happen if you then output this variable again to the console? The console will output the string thunder. This means only the instances after the declaration will take the assigned value. Even if the declaration assigns a value, any uses of the variable before the declaration will still return undefined. While it's important to understand this behavior, it's usually best practice to always assign your variables with values when you declare them. As you may have noticed, JavaScript gives you some flexibility, but you still have limitations. For example, if you try to console log a variable that hasn't been declared in your entire code, your program execution will stop. And rather than undefined, a reference error will be output. One way to think about it is that the undefined data type acts like a placeholder for a value that the JavaScript engine knows to exist. It just has not been specified. Another scenario of undefined is when you try to access an object property that doesn't exist. For example, let's say you have a game object with the property score that has a value of 1000. The property contains all lowercase words. Let's say you try to access this property, but you make a spelling mistake and spell score with a capital S. JavaScript can't find anything with this information, so it gives you the value undefined instead. Finally, let's explore the last empty value which you might be already familiar with, the empty string. This is a string without any characters inside of it, and it can be built in a few ways, such as with single quotes or double quotes with no characters in between them. In this video, you learned about the differences between null, undefined, and empty strings, as well as some of the common situations in which they appear. You've reached the end of this module on the building blocks of a program. In this module, you've discovered how to work with arrays, objects, and functions. You've also discovered how to prevent errors in your code. It's now time to recap the key topics you learned and skills that you gained. You began the module with an introduction to arrays, objects, and functions. Now that you've completed this lesson, you can explain the purpose of functions and describe their benefits, outline the process for building an array and accessing its contents, and you now understand the array characteristics and concatenation operators of strings. You can also build and call functions, create custom objects, explain how math objects work, and interact with arrays and objects. During this module, you also undertook a series of exercises in which you demonstrated your ability to utilize functions to solve simple problems, add strings to arrays, and add properties to objects. You then moved on to the next lesson, in which you explored the concept of error prevention. During this lesson, you discovered how to recognize the differences between bugs and errors, demonstrate try-catch blocks, and explain the concepts of undefined, null, and empty string values. You also completed several readings in which you learned how to recognize common types of errors in JavaScript, including syntax, logical, and runtime, and engage in defensive programming. You should now be familiar with arrays, objects, and functions, and you should also have developed your skills in error prevention. Great work! You're making good progress on your journey to becoming a JavaScript developer.
Thanks you for watching my video. Please like and subscribe my channel. Thank you for spending your valuable time with us. Your views and support mean the world to us. We couldn't do it without you. Thank you for being a loyal viewer.
When you listen to a lecture in class, the language used is probably very formal. Grammar rules are observed, and syntax and vocabulary can get quite complex based on the topic. Some other examples of the use of formal language can be found in courts and other legal institutions. Now let's consider the way people talk in their everyday life. There's lots of slang. Grammar rules are bent and broken, and the entire delivery is colloquial. There are many styles in every human language, and they all perform the exact same function: communication. The same can also be said about computer languages. They too have various styles, also known as programming paradigms. And just like in human languages, no one style is better suited than the other. In programming, there are two commonly used paradigms: functional programming, sometimes abbreviated as FP, and object-oriented programming, sometimes abbreviated as OOP. You can think of these paradigms as different approaches to writing code. But the result is still the same: instructing a computer to perform a set of operations. In this lesson, you will learn about functional programming. So let's now focus on the functional programming style. There is a clear distinction between data and functions in functional programming, as data can exist outside of functions. For example, you may recall that when functions need some data, you pass them the values in the form of arguments. Then a function performs some work on the given data and returns some values that you can then use somewhere else in your program. An alternative paradigm is the object-oriented programming paradigm, where you combine both data and functions into objects. You'll learn more about object-oriented programming later. Now let's examine a practical implementation of the functional programming style using a coding example to calculate currency conversion. Okay, so in this example of functional programming, let me start by giving my program some data. The purpose of the program is to perform currency conversions. Notice that I already have a variable declared with the name currency1 and assigned it the value of 100. Next, I'll add two more variables: currency2, which is assigned a value of 0, and exchange rate, which is set to 1.2. Notice that I have declared all these variable names using camel case. This is where the first letter of the first word is lowercase, and the first letter of the subsequent words are without spaces and in uppercase. Next, I can create the function that will work with these variables and operate on this data. First, I create a function named convertCurrency that accepts two parameters, amount and rate. Then, in the function's body, I return the result of the amount multiplied by the rate. Basically, I'm coding it to multiply the two values it receives and return the result. Next, I need to update the value of currency 2, which was previously defined on line 4, assigned to the value of 0. To do this, I call the convertCurrency function with arguments of currency 1 and exchange rate, and I assign the value returned from this function call to the currency 2 variable. Recall that when the function is invoked, it will return a value, which will be assigned to the variable currency 2. It's important to remember that I need to also pass the two arguments required for my function to work. In this example, I'm sending the variables currency 1 and exchange rate. Basically, I'm passing the values 100 and 1.2 to the function so it can perform its calculation and return the result. Finally, I console log the value of currency 2 to test my code. Success! 120 is output to the console, the result of 100 multiplied by 1.2. In this lesson, you learned about functional programming and how it can be used to solve a problem by separating data from functions. Great job!
In programming, there are situations where you need to build many objects that have a certain specific set of properties and methods. For example, you might need to build hundreds of car objects for a car racing game. To code this efficiently, you can use something called classes. They are essentially a blueprint that you can repeatedly use to build new objects of a certain kind, as many times as you like. In this video, you will learn about classes. In JavaScript, any class is built using the class keyword, followed by the name of the class starting with a capital letter, and a pair of curly braces. Inside of the curly braces, you have the constructor function, which accepts as many parameters as needed. The role of the constructor function is to assign the passed-in parameters to the future object's properties. It is the constructor function that is used when instantiating new objects, instances of a given class. After the constructor is defined, you add as many methods as you want. It's important to remember that you don't use the function keyword here, just the name of the method is needed. Once the class definition is ready, you can start building the car objects. Now that you have instantiated the car class and saved the instance of the class as car1, you have access to its methods and properties. For example, to access the turbo_on method, you type the name of the object, which is car1, then the dot, and then the name of the method that exists on that object. In this example, the turbo_on method, with a pair of parentheses to invoke it. When invoked, the turbo_on method will work with the available data in the car1 object to produce its output. Like with regular functions, you can also pass parameters to the class methods and then use them the same as with regular functions. In this video, you learned about classes and how they can be used to build multiple object instances with specific properties.
-1 semicolon. And finally, for the third line, I start by typing if, and then inside of the parentheses, I type counter $=0, and then I type return and a semicolon. If I call the function this time, it will log the numbers 3, 2, 1, and then stop. When a function calls itself, this is what's known as recursion. Recursion is an alternative way to run repetitive code without the use of loops. Next time you see someone running on a treadmill, imagine a function running in the background. It might be calling itself to continue running until its condition is met to stop. In this video, you learned about the uses and potential problems of recursive functions and how to write them so that they don't run endlessly.
Scope is all about code accessibility. It determines which parts of the code are accessible and which parts are inaccessible. For example, what variables can a function access within code? Over the next few minutes, you'll explore the concept of scope and learn about how the scope chain works within JavaScript. You will also explore some of the different scope types, such as global and local. A nice way to think about how scope works in JavaScript is a two-way mirror glass. This is a piece of glass where only one side is transparent. For example, if a restaurant uses two-way glass, people outside the restaurant can't see what's happening inside, but the people inside can see what is happening outside. The process is similar to how scope works in JavaScript. For example, the code that exists outside of a function is referred to as global scope, and all the code inside of a function is known as local scope or function scope. If a variable is defined within a function, then you can say it's scoped to that function. This is also known as local scope. For example, I could define a variable named local var and place it within a function. I could then say that this variable is scoped to the function in which it was created. Each function keeps a reference to its parent scope. This chain of scope references is referred to as the scope chain. You're now familiar with scope and how the scope chain works in JavaScript. You can also identify how some of the different types of scope work, including global and local, also known as function scope. You might recall that scope relates to code accessibility. It determines which part of the code are accessible by different parts of the program. In this video, you will explore scoping in more detail and learn about two more scope types and how they work with the keywords var, let, and const. You may recall that all the code outside of functions is referred to as global scope, and all the code inside of a function is known as local scope. Local scope states that a variable is only accessible in the function where it is declared. In the ES5 version of JavaScript, only functions can build local scope. The ES6 version of JavaScript introduced a new variety of scope known as the block scope. Block scope states that a variable declared in a block of code is only accessible inside that block. All the other code outside of the code block cannot access it. Block scope is built when you declare variables using let or const. In other words, when you build variables with let or const, they become immediately scoped to the code block they were created in. The scope of these variables is contained within curly braces. For example, you can declare two separate variables with the same name if one is declared inside curly braces and the other is not. You can then only access these variables inside their scope. Before ES6, the only way to declare a variable in JavaScript was to use the var keyword. The var keyword is very lenient. Let's outline some characteristics of variables that are declared with var. First, you can use it in your code even before it is declared. Also, you can redeclare the same variable when you use var. And the variables are scoped to a function, or if they are declared outside a function, their scope is global. With ES6, the suggested way to declare variables is to use the let or const keywords. Its syntax is very similar to the var syntax, only the keyword is replaced. For example, let's say you want to declare a variable named user and assign it to a string set to the value of Miranda. In ES5, you use the keyword var, the variable user, the equal operator, and then the string value Miranda inside double quotes. In ES6, with let and const, you use the same syntax, only changing the var keyword to either let or const. Note that the syntax is very similar. Okay, so you might be wondering, what's the difference between var, let, and const? The simplest explanation is that the behavior of let and const is more strict. With a let or a const variable, you cannot use it in your code before you declare it. You cannot redeclare it using the variable keyword, like you can with var. Finally, it's scoped to the block, even within if statements and loops, like the for or while loops. If you are new to JavaScript, it may be confusing as to when to use either var, let, or const. A pro tip is to remember it like this. Use let if the value might change in the future, and use const if the value will never change. In this video, you learned how the scope of variables changes when you use the keyword var in ES5 JavaScript and when you use the keywords let and const in ES6 JavaScript. Great job!
In this video, you'll learn about the var, let, and const variables and the different rules that they are bound to. Let's start with the var keyword. I've typed some example code that is currently commented out, but we'll go through it one point at a time. A variable declared with the var keyword can be accessed before initialization as long as the variable is eventually initialized somewhere in our code. To confirm that, let's try to console log a variable that hasn't been declared or initialized. I type console.log and then user in parentheses and click the run button. This returns reference error user is not defined, which is probably expected. However, suppose I use the var keyword to declare the variable user as my last line of code and rerun the code. Notice that undefined is output but no error. This means that the JavaScript engine continues to run. Let me clear my window here, and another thing to know about the var keyword is that we can declare and redeclare the same var variable without errors. Let me uncomment lines 9 to 13 in my code to demonstrate. Notice that each line uses the var keyword to repeatedly declare the user variable and assigns it to a different string value, Mary, Joanna, and finally Mark. I'll comment out line 15. When I run my code, it outputs the first value, undefined, and then the value of the latest reassignment, in this case, the string Mark. Next, let's move on to the let keyword. A key difference is that you cannot access a let variable before declaring it. For example, in lines 4 and 5, suppose I run a console log on the user variable as our first line. In that case, I get the reference error cannot access user before initialization. What we can do, however, is declare an unassigned variable with let. Running a console log by uncommenting lines 8 and 9 works without problems and returns undefined. However, once you declare a variable with let, you cannot redeclare it. Trying to do so by uncommenting line 12 will produce the error, syntax error, identifier user has already been declared. While you cannot redeclare a let variable, you can reassign it. For example, notice lines 8 and 15. Initially, it is set to undefined and then to the string value of Anna. Now if I run my code, notice that undefined is output first, followed by the string Anna. Finally, let me switch tabs again to demonstrate the const keyword, which is the strictest. A const variable must be initialized. For example, on lines 4 and 5, you get the syntax error missing initializer in const declaration. Next, let's comment out lines 4 and 5 and uncomment lines 8 and 9. As you can see, you can't access a const variable before initialization or else you'll get a reference error. Next, uncomment line 9 as well as line 12. A const variable can't be redeclared as it throws the type error assignment to constant variable. Okay, and that's it for this video comparing variable declaration using var, let, and const. It might seem confusing at the beginning to know which type to choose. Try to remember it like this. The var keyword is the most lenient, while the const keyword is the strictest. The best choice in use usually depends on whether or not you will be reassigning values. In modern JavaScript, I'd advise you to pick either let or const based on whether they'll be reassigned or not. Why not give it a try in your own practice code?
In programming, there is something known as the programming paradigms. You can think of this as a classification, a style, or just a general way to write code. You may already be familiar with one of these paradigms, functional programming. In this video, you will learn about another popular one, the object-oriented programming paradigm, often referred to as OOP. OOP revolves around the idea of organizing our programs using objects to group related data and functionality. This is in contrast to the functional programming approach, where the data used in the app needs to be kept separate from functions that operate on that data. Let's explore this concept further using some code examples from the two paradigms. Suppose we are asked to write some code that calculates the total cost of buying a pair of shoes. The code needs to calculate the total price, which is the shoes multiplied by the tax amount. To code this solution, you decide that you need variables to store the values for shoes and tax and total price. You need a function, which you will call total price, to perform the calculation of multiplying the shoes by the tax. Finally, you need to be able to output the result. Using the functional programming approach, you clearly separate a program's data from functions that work on that data. With the OOP approach, you create an object and store all data related to that object, including variables, functions, and output statements. For example, you create an object named purchase1. You may recall that functions inside objects are known as methods. Now that the purchase1 object is created, you access the total price method on the purchase1 object using the dot notation. Then you invoke the total price method, which works with data inside the purchase1 object and returns the result of 120. In fact, you can access any data that the purchase1 object has. For example, using the dot notation, you can access the shoes price data and the state tax data. An advantage to using the OOP approach is that you can build as many objects as you need. For example, you can build another purchase object and name it purchase2. Once created, you can also access the total price method on the purchase2 object, just like you did on the purchase1 object previously. You may notice that the total price method was almost the same in both the purchase1 and the purchase2 objects. This means that you can improve the objects so that both methods are identical. And you can do that by using the this keyword, which you may recall. It essentially means this object. It's important to note that the code still works exactly the same as before. Okay, so you may be wondering, why did I go through the trouble of updating the code of purchase1.choosePrice to this.choosePrice? Well, the advantage here is that rather than having to think about the name of the object whose shoesPrice property I'm trying to access, I just use the alias of the current object's name, namely the this keyword. And now I can just copy the total price method from the purchase1 object and reuse it in the purchase2 object. So, using the this keyword allows me to not really care about the current object's name, which is an improvement to the previous code I had. However, programmers are always eager to avoid wasting resources when writing code, and coding a custom method on each of the objects I build is wasteful. The solution to this is to code my objects using some sort of a template. You will learn how to create this later in this lesson using something called a class. For now, let's explore object-oriented programming principles with the example of calculating the total cost of buying a pair of shoes. Before starting, let's first quickly revisit another programming style, functional programming. This should help you understand the differences between the two paradigms. I start with var shoes equals 100, and I also add var state tax equals 1.2. Next, I declare a function which returns the value of the shoes multiplied by the value of the tax. This is written as function total price with shoes and tax in parentheses. Inside of curly braces, I add return shoes asterisk tax. Now I'm declaring the variable to pay, which invokes the total price function and passes the shoes variable value, as well as the state tax variable value. Finally, I console log the toPay variable. When I run the code, the output is 120. So that's an example of the functional paradigm. But this time, let's build something similar with the OOP paradigm. I go to a separate file where I declare the variable purchase1 and store an object literal inside of it with curly braces. I then add the property shoes and set it to 100, followed by state tax, which is set to 1.2. The last property is total price, which is set to a function to declare a calculation variable. This variable is equal to the purchase1.choose property multiplied by the purchase1.stateTax property. The second part of the function console logs the string total price, along with the value of the calculation variable. On line 10, I call the function with purchase1.totalPrice parenthesis, which I expect to return a value of 120. I run the code, and that's indeed what I get. On another file, I'll build another OOP example. This one starts with the variable purchase2, which has the same structure as purchase1. However, the shoes value is changed to 50. In the total price function, the calculation variable is updated to access the shoes and state tax properties from purchase to. When I invoke the total price method on the purchase to object and run the code, it returns a value of 60. Between these two OOP examples, you may have noticed that aside from accessing the shoes and state tax properties in different objects, the two methods are completely the same. This means that I can improve my objects to make both methods identical while getting the same results. I can do this using the this keyword, which essentially means this object. Let's move to another file to examine how that works. In this file, I have the same purchase 1 and purchase 2 objects from before, with all of the same values. In the total price function of purchase 1, I replace the references to purchase 1 with the this keyword. I can then copy the total price method from purchase 1 and paste it into the purchase 2 object, since they are now identical. I run this code and it gives me a total price of 120 for purchase 1 and 60 for purchase 2. This is an improvement over my original code from the perspective of reducing waste. Instead of writing custom methods for every object, this approach allows for the reuse of existing code. However, although I'm reusing the existing code, I'm now repeating this same method on each new object that is built. That is wasteful, and programs need to be efficient. This is where making templates for objects comes in. In JavaScript, one of the most elegant ways to efficiently build new objects is by using classes. Congratulations! In this video, you learned about object-oriented programming and how it differs from functional programming. With the object-oriented approach, you can code more efficiently by reusing existing code. In programming, there are situations where you need to build many objects that have a certain specific set of properties and methods. For example, you might need to build hundreds of car objects for a car racing game. To code this efficiently, you can use something called classes. They are essentially a blueprint that you can repeatedly use to build new objects of a certain kind, as many times as you like. In this video, you will learn about classes. In JavaScript, any class is built using the class keyword, followed by the name of the class starting with a capital letter, and a pair of curly braces. Inside of the curly braces, you have the constructor function, which accepts as many parameters as needed. The role of the constructor function is to assign the passed-in parameters to the future object's properties. It is the constructor function that is used when instantiating new objects, instances of a given class. After the constructor is defined, you add as many methods as you want. It's important to remember that you don't use the function keyword here, just the name of the method is needed. Once the class definition is ready, you can start building the car objects. Now that you have instantiated the car class and saved the instance of the class as car1, you have access to its methods and properties. For example, to access the turbo on method, you type the name of the object, which is car1, then the dot, and then the name of the method that exists on that object. In this example, the turbo on method, with a pair of parentheses to invoke it. When invoked, the turbo on method will work with the available data in the car1 object to produce its output. Like with regular functions, you can also pass parameters to the class methods and then use them the same as with regular functions. In this video, you learned about classes and how they can be used to build multiple object instances with specific properties. In the real world, inheriting something means acquiring possession, condition, or trait from past generations. In this video, you will learn that inheritance also exists in JavaScript, and the inheritance model revolves around something called the prototype. You may also be familiar with the concept of a prototype, which is often referred to as an original model from which other forms are developed. In JavaScript, the prototype is an object that can hold properties to be shared by multiple other objects. And this is the basis of how inheritance works in JavaScript. This is why it's sometimes said that JavaScript implements a prototypal inheritance model. Let's explore this further now with some code examples to demonstrate inheritance and how to build a prototype. Consider the following object. I'm setting the var bird to an object that has 3 properties, each set to the Boolean value of true. The properties are has wings, can fly, and has feathers. Using the readily available object create, I can construct new objects. For example, I've set the eagle1 variable to a call that takes the bird object and passes it to the object.create method. I can console log the contents of the eagle1 object now. Let's run the code. And notice an empty object logged to the console. However, since I used object create to instantiate the eagle1 object, I also have access to all the properties of the bird object. So, I console log eagle1 has wings and pass eagle1 dot has wings. And I also console log eagle1 can fly and pass eagle1 dot can fly. And finally, eagle1 has feathers, passing it eagle1 dot has feathers. Let's rerun the code. Once again, notice eagle1 has wings true, eagle1 can fly true, and eagle1 has feathers true, our output to the console. With the object create syntax, I can build as many objects as I want, and they will all have the bird object as their prototype. Here, notice that I built an eagle2 object, and I've used the bird object as a prototype, because I ran the object.create method on it, and I save everything to the eagle2 variable. It's important to understand that the eagle2 object also has access to the properties stored on the bird object as its prototype. Let's run this code to confirm. And indeed, notice that eagle2 has wings true is output to the console. I can even add different objects with different behaviors. For example, I can add a penguin1 object. I do this by declaring a penguin1 variable and assigning the result of the object.create method to it. Penguins are flightless birds, so I want to set the can fly property to false. Thankfully, this is a relatively straightforward process because JavaScript starts from the object itself when looking for properties to work with. Then, if it can't find it on the object, it looks up to its prototype. It's important to remember that it doesn't look further if it finds the property on the immediate object. This makes for a simple mechanism for overriding inherited properties. So let's implement this now. First, I set the can fly property on the penguin1 object to false. And now I can console log the penguin1 object. Notice the output to the console after running the code is that penguin1 is an object with a can fly property set to false. Additionally, I can still access all the properties of the prototype. So accessing the has feathers and can fly properties of penguin1 will return the values that are stored on the prototype when I run the code. However, the can fly property is now set on the penguin1 object itself, so it overrides the can fly property on the prototype. This override only affects the penguin1 object. It doesn't change my prototype or other eagle objects. In this video, you learned about inheritance in JavaScript. Although it is possible to build inheritance using the object create method, it's probably better to use class syntax for more complex objects and inheritance. Although under the hood, this syntax still works with prototypes, it makes sense to use classes as they improve developer experience in more complex scenarios. Have you ever needed to apply the formatting of text in a word processor from one portion of text to another? In essence, you are copying the properties from some text that is already formatted and applying them to another piece of text that you want to format. In a similar way as with text, JavaScript objects can have properties that define their characteristics. In this video, you will learn how to destructure objects and arrays, and also how to use the destructuring syntax to extract new variables from objects and arrays. To illustrate destructuring, imagine that an object or an array is like a project folder that you have on your computer with several files in it. Destructuring something out of an object or array, in this case your project folder, is like copying that item from your folder onto another location. The original item still exists in your project folder. I just made a copy of the original item, but this copy is completely independent of the original item. Now let's explore an example with an existing built-in math object to destructure the value of pi from it. Let's start by using the let keyword and surround the uppercase pi in curly brackets equals math. Because I already know that the pi property exists on the math object, I make a copy of it and I save the new object in a separate variable. I name pi. Note that I can only destructure something that already exists on an object. Using faulty spelling, including lowercase, won't work and will return an undefined value. If I type let open curly bracket, small case pi, close curly bracket equals math, pi returns as undefined. This is because there isn't a lowercase pi property on the math object. So, when I try to destructure it, I get the value of undefined for the lowercase pi variable. The next step is to confirm that all caps pi variable has the identical value and data type as math.pi by using the triple equals strict comparison operator. This will return a value of true. To prove that the destructured property and the original property are in no way connected, I update the value of the pi variable to be 1 by typing pi equals 1. I can now compare all caps pi and math.pi again by typing pi triple equals sign math.pi, thus getting back the Boolean value of false. It's clear that these two are no longer the same. The only reason why this worked is because the original property on the object and the destructured value are not connected in any way. In other words, there's no connection between the destructured variable and the source property on the given object. In this video, you covered how to destructure objects and arrays, and also how to use the destructuring syntax to extract new variables from objects and arrays.
In this video, I'll help you understand the difference between for-in loops and for-of loops when applied to objects in JavaScript. At first, this code may appear complex, but you'll find that it only involves concepts that you've dealt with before. So, let's begin by breaking down what I have. I have a const set to an object and assigned to a variable named car. This object has three properties, engine, steering, and speed, which are given the values true, true, and slow respectively. I also have a const assigned to the variable sports car, and I've used object.create so that it inherits the properties of the car variable. Then I set the speed property of the sports car to fast and save it to the sports car variable. I've also added a console log to display the string, the sports car object, followed by the properties of the sports car object. Next, I have two for loops. The first one is a for-in loop written to log the properties of the sports car object. This is typed as for, followed by properties in sports car in parentheses. Inside of curly braces is a console log for prop, so it displays the properties of the sports car. Before and after the for-in loop code, I've written console logs to print some comments which will be addressed after I run my code. My second for loop uses the object keys method on my sports car object, which should iterate over that object. This is typed as for, followed by prop of objects.keys sports car inside of parentheses. Inside of the curly braces is a console log for prop plus a colon in double quotes, and sports car with prop enclosed in square brackets. I've also console logged another comment after this code. When I run this code, I get the output, the sports car object is speed fast. It also displays the comment I had in the code, for-in is unreliable. Let's explore why. From the for-in loop, the console logged values might surprise us. It loops over the property in the sports car object, but the output includes the properties on the sports car's prototype too. Instead of just the speed property, I also looped over the engine and steering properties, which exist on the prototype of the sports car object, not on the sports car object itself. In fact, as the comments state, for-in loops are unreliable in this scenario because they iterate over not only the specified object, but also its prototype. That's why I used a thinking emoji in my comment with the string iterating over object and its prototype. Now, let's examine what came from the second for loop, which is a for of loop. Note that I output the comment I had in the code for of is reliable. I've gotten back speed fast, or in other words, the property and value that I've assigned to the sports car object. And just as I have stated in the comment in my code, this is because a for of loop only iterates over the object's own properties and does not count the prototype at all. Hopefully, you are able to differentiate between the for in and the for of types of loops. Let's run a simplified version of the same code without the comments. I'll switch to my other file. This time around, my car object only has an engine property. Then I am declaring the sports car variable and I am setting the car object as the sports car prototype. I'm also setting the speed of the sports car as fast. And finally, I'm console logging the sports car object and looping over prop in sports car and props of object keys in sports car. In summary, the two loops are simplified. I am only console logging a thinking emoji and the props value for the first loop, the for in loop. And I'm only console logging a bullseye emoji and the prop and its value in the for of loop, that is, the second loop in my code. When I run the code again, the result is much simpler. First, I confirm that the sports car object only has one single property, speed, which is fast. Then, the for in loop displays speed and engine because engine belongs to the prototype of the sports car object and not the sports car object itself. And finally, the for of loop outputs looping over only the sports car object properties, which in this case is only the property fast. The emojis from my code appear alongside these properties and help us to understand what they mean. And just to sum it up, the speed and engine properties are from the for in loop because it draws from the prototype of the sports car object as well as the object itself. The speed fast property, however, comes from the for of loop since that iterates over the sports car object's property only. In this video, you learned that when you run on objects in JavaScript, for in loops iterate over the properties of the object and its prototype, while for of loops do this only for the object's properties. In this video, I'll guide you through creating and using template literals in JavaScript ES6 to understand their benefits. First, let's revisit strings in JavaScript ES5, which are built using single quotes or double quotes. I have an example in my code. I've declared a variable no multiline with the let keyword, which holds the string value no multiline strings in ES5. On the following line, I'm using the console.log method to output the string did you know, followed by the plus operator, and then finally the no multiline variable. Recall that you can use the plus operator for concatenation. When I run the code, I get the expected output of did you know, no multiline strings in ES5. This time, let's change the value of the no multiline variable. To do this, I place my cursor after the word no and press the enter key to move part of the string to a second line. This now spans the string over multiple lines. If we were to run this code now, we would get the error. Also, notice that VS Code is trying to warn us about this error by highlighting the end of lines 3 and 4 with red text and displaying the message unterminated string literal. This is basically JavaScript telling us that our single line string is not coded correctly with the expected closing double quotation symbol. Using ES5 methods, you can only create strings using single or double quotations, and using this method does not support the use of multiline strings. Next, let me clear the output and switch tabs in my code. Here, we have some syntax that may be unfamiliar to you. We have a variable multiline declared with the let keyword, and it contains a string. Like the previous example, this string is distributed across several lines. However, instead of quotes, it's encased within a pair of backticks. This turns it into an ES6 expression known as a template literal. The backtick symbol is usually located above the tab key to the left of the 1 key on your keyboard. Still, it's a good idea to check your device's documentation as you may be using a different keyboard layout. Using template literals, you can add as many lines as you want without causing errors. I can confirm this by running my code. Notice that the output is a multi-line string. But wait, it gets better. We can combine template literals with variable interpolation for even more flexibility. Once again, let me clear the output and continue to the next tab. Here, notice I have two variables called first and second. each containing a single-line string encased in backticks. But there's a twist here. Each string also has a segment that sits inside of quotes. Wouldn't this cause conflict, you might wonder? Fortunately, that's not the case. By using template literals, JavaScript does not consider quotes as string delimiters, meaning they are just regular characters here. Now I can use template literals again to interpolate the variables first and second on a different line. Instead of using the plus operator for concatenation, I can simply enclose the full desired string within backticks. I can then place the variable name by enclosing it within a set of curly braces preceded by a dollar symbol. If I run this code, JavaScript combines everything and outputs the full string. With template literals, you don't need to worry about the limitations of using single and double quotes. This can make for a much better coding experience, as you just need to use backticks and variable interpolation. And that's all for this video. Well done! You learned how to build and apply template literals to create multi-line strings and interpolate variables in JavaScript.
Suppose you receive some data on students' test results, and your task is to write a program that outputs an average grade from all the tests based on the raw data. Before you can code this task, you need to consider two separate issues. First, how do you represent the given data in your app? And second, how do you code the solution? Before you even start coding a solution, you need to think about how you will represent the data. In this video, you will learn about some of JavaScript's most common data structures, such as objects, arrays, maps, and sets. A data structure is a way to organize data. For example, you could represent it as a string. However, it would be somewhat of a strange representation. You'd need to somehow extract the numbers from the string before performing calculations on them. Alternatively, you could represent it as several numbers, each number saved in a variable. Doing it this way, you don't have to extract and convert strings to numbers. But is this the most efficient way of storing your app's data? Perhaps another approach would be to store all the grades in an array. This way of organizing your data is even more efficient. It involves less typing and regrouping related data together under a single label. You may recall the many benefits of using arrays, but what is important here is that you understand how you code a solution to a given task depends on how you structure your data. In other words, a solution to a coding task depends on the data structure you use. JavaScript is somewhat limited in the types of data structures available compared to other programming languages such as Java or Python. However, some of the most common that you will encounter are objects, arrays, maps, and sets. You may be familiar with some of these already. Let's explore each briefly now. You may recall that an object is an unordered, non-iterable collection of key-value pairs. And you use objects when you need to store and later access a value under a key. An example of using this data structure is when you need to write object-oriented or OOP code. Similarly, you may also recall an array, which is an ordered, iterable collection of values. Likewise, you use arrays when you need to store and later access a value under an index. And remember, we do not specify the index. JavaScript does this automatically. You only use the index to access the specific value stored in the array. When working with arrays, it's common to use a loop, such as a for loop, to access and edit the data. For example, to find the average grade for the task earlier, you could loop over the array and calculate the total sum. Then, after the for loop, calculate the average by dividing the sum by the length of the array. The next data structure is map, which is like an array because it's iterable. However, it consists of key-value pairs. It's important not to confuse a map with an object. With maps, any value can be used as a key. With objects, keys can only be strings or symbols. Finally, the last data structure I want you to know about is a set. This is another collection where each item in the collection must be unique. For example, if you try to add a non-unique item to a set, this operation will simply not be run. In other words, No errors will be thrown and no updates will be made to a set. In this video, you learned about some of JavaScript's most common data structures, such as objects, arrays, maps, and sets. Which one you need to use depends on the task at hand. Next time you have a coding task, try to think of the data structures you might use. The spread operator is another of the many great new additions that came to the JavaScript language in its ES6 update. It is the shortest and simplest method to copy the properties of an object onto a newly created object. Think of the spread operator as a magical multi-purpose tool that can spread out array items and join objects together. In this video, you will explore what the spread operator is and how to use it. Note that the spread operator is characterized by 3 dots. To illustrate where the spread operator becomes useful, let's first build an array, and then call the items with a basic function. Using the variable keyword let, I create an array of the top 3 places to visit on a holiday to Rome, and I call it top 3. Then I include the Colosseum, Trevi Fountain, and the Vatican City as the elements of my top 3 array. Now I write a function that lists these 3 attractions. To keep it simple, I just log it into the console. I create a function and I name it showItineraries with 3 arguments: place 1, place 2, place 3. Now I console log the 3 places to visit by typing console.log and then the string visit and the first argument place 1. Next, I console log the other 2 arguments by first using the strings, then visit, and the argument place 2. And then the string finish with a visit to, and the third argument, place 3. Then, when I run the function showItineraries, it should run through all 3 places. Now, let's try to run the showItineraries function with the elements in the top 3 array. I write the function name, showItineraries, and each array element, starting with top 3, open square bracket, 0, which is the first element in the array, and close square bracket. Then I do the same for the other array elements, 1 and 2. But what if I extended my function to have 7 places that I want to visit? Let's disregard what the showItineraries function definition may show and imagine that I have made the necessary updates so that the function will handle 7 arguments. I have now built an entirely new array of the top 7 destinations, and I have saved it in a variable named top7. Now, I call the showItineraries function, and passing this function, the 7 arguments again start with 0, as in top7 and 0 within square brackets. Then the array again, top7, and number 1 within square brackets, and so on, until we get to the last top7 array element, which is top7 and number 6 within square brackets. While this code will work, it seems a bit impractical. The spread operator simplifies things. Let's try it now. I type the showItineraries function, then open parenthesis, 3 dots, top7, close parenthesis, semicolon. That's it. I used the spread operator by placing it in front of an array, which is passed to the showItineraries function. The advantage of this approach is that you don't have to list each individual member of the array that you want to pass to your function. The syntax is clear, concise, and easy to type. Now, if I go back to the top 3 array, I can use it with the spread operator just like I used it for the top 7 array. I type the showItineraries function and the 3 dots, and the array name, top3, within parentheses, and I end with a semicolon. The function returns the combination of the strings and the variables I used earlier. Visit the Colosseum, then visit Trevi Fountain, and finish with a visit to the Vatican City. In this video, you explored what the spread operator is and how you can use it. You might already know that a spread operator in JavaScript is used to unpack a box, for example, to unpack an array. The rest operator, on the other hand, is used to build a smaller box and pack items into it. In this video, you will explore what a rest operator is and how to use it. To illustrate how a rest operator can be useful, consider a travel itinerary. I've realized that there are many things I'd love to see while in Rome during my vacation. Unfortunately, I'm pressed for time, and there's no way to really enjoy all of the attractions, even if I rush to see them all. Let's explore how to solve this itinerary issue. In this case, I can create an array of 7 places that I would like to visit on my holiday to Rome. So I type const top7 to create the array, and I list the 7 places I would like to go within square brackets, with each item in double quotes and separated by a comma. The Colosseum, the Roman Forum, the Vatican, Trevi Fountain, the Pantheon, Piazza Venezia, and the Palatine Hill. To solve the problem, I decide to organize my list in such a way that I have my top 3 attractions and prepare another list for a second visit. To do this, I use the REST operator and a technique known as destructuring. In this destructuring syntax, I simply specify what I want to get out of the top 7 array, in this case, the first 3 items. So, I start by typing const, open and close square bracket, =, top 7. Then I create 3 variables, first, second, and third, plus another variable to hold the rest of the list, named second visit. To do this, I type const first, second, third, and then 3 dots and a new variable, second visit, within square brackets, then equals top 7 semicolon. With this syntax, I extracted the contents of the top 7 array into 4 variables. The variable first with the value of the Colosseum, the variable second with the value of the Roman Forum, the variable third with the value of the Vatican, and then I include the variable second visit. That is a subarray of the rest of the items in the original top 7 array. If I inspect second visit, an array of the 4 remaining attractions, Trevi Fountain, the Pantheon, Piazza Venezia, and the Palatine Hill, are all saved as string primitives. The REST operator, therefore, gives us what is left over of the source array as a separate subarray. The REST operator is also useful in functions too. In fact, I can use a REST parameter to quickly multiply values. I create a function to add the tax rate to prices. I name it add tax to prices and give it 2 parameters, the tax rate and the REST operator with the items bought. The function returns each item with the tax rate. In the add to tax prices parameters, the REST parameter gives me an array, so I can use array methods on items bought using the map method. It's important to know that the REST parameter must be the last parameter in the function definition. This means that adding any other parameter to my add tax to prices function after the REST operator and the items bought would result in an error. In this video, you learned how to use the REST operator, which groups the remaining parameters in a list within a standard JavaScript array. Well done with completing this video on the REST operator. Hello and welcome. Photographers often need different camera lenses for different shooting situations. It wouldn't be very economical to have a separate camera for every need that arises. Fortunately, most systems are modular, meaning the lens can be removed and replaced with a different one as needed. In JavaScript, complex programs can be useful for multiple applications, and it wouldn't make sense to rewrite them over and over. Thankfully, since version ES6, they can be saved and used elsewhere as modules. In this video, you'll cover what modules are in JavaScript, which includes how they work as well as their current limitations. You'll also explore how to use simple ES6 modules in a browser. JavaScript modules are standalone units of code that you can reuse again and again. Being standalone means that you can add them to your program, remove them, and replace them with other modules, and everything will still work. But before we continue, let's explore what things were like before modules entered the picture. In all versions of JS, all functions that are defined on the window object are global. While useful for simple projects, this created some issues when third-party libraries or multiple developers became involved. For example, a global function from one script could override a function from another one using the same variable name. Techniques were developed to bypass these issues, but they were not without flaws, and so, for a long time, JavaScript lacked built-in, natively supported module functionality. An engineer at Mozilla named Kevin Dangour tried to fix this through a project called Server.js, which was later renamed to CommonJS. CommonJS is designed to specify how modules should work outside of the browser environment. It is mostly used on server-side JavaScript, namely Node.js. A downside of CommonJS is that browsers don't understand its syntax. That is, certain keywords that CommonJS relies on, such as require and module.exports, don't work as expected in browsers. You can learn more about other module systems in the additional reading. But now that you know a bit of the history, let me demonstrate ES6 modules in action. To understand how ES6 modules work, we need to go back to the humble HTML script tag. The script tag comes with a type attribute, which identifies the type of content that it contains. For JavaScript, it is written as script type equals, followed by text/JavaScript in double quotes. To display text in a browser, on the next line I've typed console.log, followed by the string hello from script tag in parentheses, and then a script closing tag. I can even omit the type attribute and use a basic script tag, and the attribute will be set to text/JavaScript by default. To make that happen, I've input an open script tag followed by console.log on the next line and same sample text. I've then added a few more console logs before closing off the script tag. To verify that these script tags work, I'll open a local HTML file in my browser that is linked to this code. When I open the Elements tab in the Developer Tools, it displays the script tags, while the Console tab shows the console log output. Next, let's explore how we can use ES6 modules in a browser. Before starting, I'll open a separate code document. Now, I've changed the value of the type attribute by typing the script tag script type equals module. I've then imported a module called greeting.js. But how do you make it work? To demonstrate, I'll open the associated HTML file in another browser tab. Since I'm running this file locally, access to my script is blocked by a built-in browser security feature called cross-origin resource sharing, and I receive an error message under the Console tab. To eliminate this error, I need to run the HTML file over a server. I can use a local server for that. For information on how to set up a local server, refer to the additional reading. Now, my greeting.js module is being read in and consumed by this HTML document script tag. In other words, the file script tags have successfully imported the module. In this video, you've learned about modules in JavaScript ES6. You should now have a better idea of both their uses and their limitations, and you should know how to use basic ES6 modules in a browser. Did you ever think of the functions your TV remote does for you? It allows you to make changes to your TV. You can think of the DOM like a TV remote that lets you change the web page content on the screen. It even allows you to replace only certain parts of the page, such as an image or the heading, or both. A remote, however, has certain limitations. You can only change the channel, contrast, brightness, and volume. The DOM gives you much finer-grained control than a TV remote ever could. For example, imagine you can change what characters in a TV movie look like with a few simple commands while the movie is playing. The DOM allows you to change properties of objects on a web page. You can think of the DOM as a superpower remote for websites. It gives developers power in how they can manipulate and update web pages. The DOM is in the form of a JavaScript object with nested objects for different parts of the page. These objects have nested objects of their own until the entire HTML file is mapped out in what looks like a tree structure. The DOM is the model of the HTML file saved as a JavaScript object in your browser's memory. The browser automatically builds the DOM for every web page that it downloads. For example, if you type a URL into your browser's address bar, the browser will fetch the web page that exists on this domain. If the browser connects to the server and it allows the browser to download the page, it will receive all the HTML code and save it in its memory. The browser will then show the downloaded page. It will also build that web page's DOM, a model of the HTML document your browser has just downloaded. As a developer, you can interact with the page's DOM to make changes to the web page. To interact with the DOM, you can use the Elements tab inside the browser's DevTools. You get to the DevTools by right-clicking anywhere in a browser window and then by clicking Inspect. The Elements tab allows you to interact with the DOM of the currently active web page using a graphical user interface, also known as a GUI. The browser also allows you to interact with the DOM using JavaScript. To do this, you should click the Console tab in the browser's DevTools. You can focus on the console panel by pressing the Escape key on your keyboard. Once done, you can start typing JavaScript commands to view and manipulate the DOM. This is similar to how you interact with the DOM using the Elements panel, only this time you're using code to do it. The entire DOM object is saved inside the document variable and accessible via the console. Now let me demonstrate how DOM manipulation works. Using the document object model allows us to manipulate live websites. For example, I've opened my browser and loaded the example.com webpage from the internet. I want to add a heading 2 HTML element to this webpage using the DOM. Once again, I have the developer tools open in the window to the right, and the console tab is active. It's important to remember that any changes I make to the DOM are relative to my browser's local copy of the web page. I'm not updating the content of the live website, so don't worry, you are not going to break it. If I reload the web page, all changes I make to the DOM will be lost, as it will reset to the page that was downloaded from the server. Okay, so in order to create my heading 2, I need to update the document object. To do this, I type document dot and then the method createElement. Then, inside the open and close parenthesis, I type the name of the HTML element that I want to create, which is wrapped around single quotes. What I am doing here is passing the tag names as a JavaScript string. Finally, I'm going to assign this statement to a const variable. So, I type const h2 and then the assignment operator. I press enter, and now I have successfully built my h2 element. You may notice that the web page on the left has not been updated with the heading 2. This is because although I now have a h2 element saved in JavaScript's memory, I still need to attach it to the DOM structure. Currently, it's not a part of the document object. Additionally, my h2 element also needs some text. Without it, even after adding the h2 element to the document, there would not be a visible change on the page because the added h2 element, although being a part of the DOM, would have no text inside. In other words, it would be blank. Let's fix these two issues now. First, I'll make some updates to my h2 element. I'll add some attributes and some text using the innerText method. I can run this on my h2 variable. I type h2.innerText and then assign a string with a value of this is an h2 heading. Next, I want my heading 2 element to have an ID and a class HTML attribute. To do this, I need to use the setAttribute method. So I type h2.setAttribute, which takes two parameters. The first one is the attribute's name, which is ID, and then the value of the attribute. For this example, I'll name it subheading and press enter. Notice that inside the parenthesis, the name and the value are wrapped in single quotes and separated by a comma. Next, I need to use the setAttribute method again, this time for the class attribute. I've pasted the same line of code and now I just need to change the word ID to class. And for the value, I change this to secondary and press enter. Finally, I'm ready to append my h2 object to the DOM. First, I can test that my code is correct by typing h2 and noticing the HTML structure's output. This looks good to me, so let's add it to the DOM. I need to run the append child method on the document body to do this. So now I type document.body.append child, and inside the parenthesis, I place my HTML structure stored in the variable h2. Success! My object is appended to the body of this web page, and the heading 2 text displays in the browser. You should now be able to explain the basics of DOM manipulation and use some of the most common DOM manipulation methods.
One of the most powerful features of JavaScript is DOM manipulation. For example, you can click on a button and change the color of some text or even display a pop-up message. Essentially, you're dynamically updating the HTML content in real time. To do this, you must be able to locate the objects in your HTML document that you want to manipulate. In this video, I'll guide you through how to use selectors in JavaScript to quickly find specific objects in a document. JavaScript selectors work with the document object, which you can access by typing the keyword document. This returns the web page stored in the browser's memory, known as the document object model, or DOM. Alternatively, I can run a console log on the document keyword to get the same result. Let's start locating specific elements inside the document object using the query selector method. For example, I know this page contains 2 HTML paragraph elements. To access the first one, I type document.querySelector, then in single quotes inside of the parentheses, I type the letter P. When I press enter to run the command, it returns the first P element. I can then expand this to view the paragraph text contained within. This method can be used with other HTML elements such as the anchor tag. If I run the same command with the letter A, I get back the first anchor element on the page. There is a very similarly named JavaScript selector that allows me to get all the matches from a web page. It's the querySelectorAll method. To demonstrate this, I type document.querySelectorAll. Inside the parentheses, I pass the P letter as a string, and indeed I get back a result that shows that there are 2 paragraph tags on this page. Another useful JavaScript selector is getElementById, which can find objects in the DOM that match a specified HTML ID attribute. For example, let's say we want to find something on this page with the ID of heading. I type document.getElementById and then the string heading in parentheses. I press enter and notice that an h1 element is returned assigned with the HTML ID attribute value of heading. Next, let's use a similar method that returns an element based on a specified class name rather than ID. We can do this by calling document.getElementsByClassName. I type document.getElementsByClassName and then the string txt in parentheses. Again, I press enter and notice that 2 results are returned, the 2 paragraph tags containing the class name of txt. If you are a beginner on your journey with JavaScript, it is important to note that the word element is singular for ID and plural for class name. Additionally, suppose the element you are looking for cannot be found. In that case, you will be returned null for IDs and empty collection represented by square brackets for class names. In this video, you learned how to use JavaScript selectors to speed up the process of finding specific objects in a document.
Let's say you are using a web page on your computer and you click a button, or you tap the like icon on a friend's picture on your phone. In JavaScript, the button click and the like icon tap are examples of user-triggered events. Events are happening all the time. You can use JavaScript code to listen for these events. You can even choose the parts of the page on which you are listening for events. Let me describe an example. You might want to listen for a click event on an Add to Cart button. Once you capture such an event, you might want to run some JavaScript code. For example, I can add a circle with the number 1 on it next to the shopping cart icon to indicate that there is now 1 item in the shopping cart. If the same event gets triggered or fired again, Our event handling code then handles the event by updating the count in the circle next to the shopping cart icon. The circle then displays the number 2 to indicate that there are 2 items in the cart. In JavaScript, the function that handles captured events is known as the event handler. Let me demonstrate how to listen for an event by using the addEventListener method. Okay, so I'm back in the console here, and let me demonstrate 2 ways to set up an event listener for HTML elements on a web page. One of the easiest ways to listen for an event is to use the addEventListener method. You can do that on a given HTML element. For example, suppose I want to listen to the click event on the body of this example website. First, I need to get a reference to the body element where we want to listen to this event. In the console of the browser developer tools, I type document.querySelector and then the name of the element inside of the parenthesis. For this example, it's body, and I enclose it with single quotes. Next, I want to assign the body object to a variable, so I type const target equals to assign the body object to the target variable. I've named this variable target because it's the target of our click event. Now I can create a function that will be run when this target is clicked. So I type function handle click, and then in the function body I console log the string clicked the body. The next step is to run the addEventListener method on the target element. So I type target.addEventListener. Then, inside the parenthesis, I pass it 2 arguments. The first is the event type click as a string value, and the second is my handle click function. Okay, so my code is now ready. Let me test it by clicking the web page. Success! Notice that the text is output to the console. In addition to the addEventListener method, an alternative way to listen for events is by using HTML event attributes. Before doing that, let me first write a second click handler function named handleClick2. Once again, I console log a string inside the function body. This time, it will output the phrase clicked the heading. Next, I need to open the Elements panel of the developer tools and expand the view for the div element. Then the heading element should be visible. I right-click the H1 element and click Edit as HTML. Then after the H1, I create the attribute by typing onClick equals, followed by my function name, handleClick2, with a pair of parentheses at the end. Finally, I click outside the element to save the change and return to the console tab. Notice that when I now click on the heading in the web page, the phrase clicked the heading and clicked the body is output to the console. Basically, this single click has triggered 2 different event listeners, but notice that if I click outside of the heading, it only triggers the event listener that listens for clicks on the entire body element. In this video, you learned how to write an event listener using the addEventListener method, as well as by writing a function directly as a HTML event attribute. Great work!
In this video, I'll help you learn to convert a JSON string to a regular JavaScript object and vice versa. If you type a piece of JSON code into your browser's console, it should not produce any errors. For example, a JSON string with one property named greeting that contains the value of the string hello. If I run this code, I get back the same result. It's worth remembering that JSON is basically just an object represented in the form of a string. It has some specific formatting, but it's a string nonetheless. So to work with JSON, it is common to convert it back to a JavaScript object to work with its properties and methods. To do this, you need to use the global built-in JSON object and its parse method. Let me demonstrate this now. First, I will assign the JSON string to a variable named JSON_str using the const keyword. Next, I'll run the JSON parse method on this variable by typing json.parse and then JSON_str inside the parentheses. I press enter and notice that a regular JavaScript object is returned. I want to save this object as a variable, so I assign the JSON parse method to a variable named aplaneobj using the const keyword. Okay, so now that my JSON string is stored in a regular JavaScript object, I can manipulate it just like any other JavaScript object. Let me demonstrate this now by reassigning the value of the greeting property. I type the object name, followed by a dot, and then the object property equals hi. Press enter and notice that the word hi is output. I can confirm this by inspecting the object and notice that its structure has been updated. Okay, that's how you convert a JSON string to a JavaScript object. You can also go the other way and convert a regular object to a JSON string using the stringify method of the JSON object. Let me demonstrate this now. For example, let's start by declaring an object named data and assign it some properties and values. To run the JSON stringify method on this object, I type json.stringify and place the object's name inside the parentheses. The result is a JSON string. Notice that both the object's keys and its values are double-quoted strings in the JSON syntax. It's important to remember that while plain JavaScript objects can hold functions, JSON strings cannot. Another limitation is that valid JSON doesn't allow the use of JavaScript comments. Also, when you stringify a JavaScript object containing a method, that method will be excluded from the stringify operation. In this video, you've learned how to convert a JSON string to a JavaScript object with the parse method, and how to convert a JavaScript object to a JSON string using the stringify method. If you work with retrieving data from APIs, converting the JSON strings to JavaScript objects will be a standard workflow. You can then easily access the object's properties programmatically. This is a vital tool in your tool belt, and I encourage you to practice this.
You've reached the end of this module on programming paradigms. Great work. During this module, you explored the core features of functional programming and object-oriented programming. Let's review the module by summarizing the major items you encountered. The various styles of computer languages are known as programming paradigms. Having studied programming paradigms in this module, you should be able to describe functional programming and how it can be used to solve a problem by separating data from functions. Having explored functional programming, you moved on to another popular paradigm, object-oriented programming, often referred to as OOP. You discovered how OOP differs from functional programming, and you studied object-oriented programming principles. In programming, scope determines which parts of the code are accessible and which parts are inaccessible. You learned how the scope of variables changes when you use the keyword var in ES5 JavaScript, and when you use the keywords let and const in ES6 JavaScript. You should now be familiar with how the scope chain works in JavaScript, and you should also now be able to identify how some of the different types of scope work, including global and local. Much of the development work in JavaScript involves building objects. Classes are essentially a blueprint that you can repeatedly use to build new objects. You can also pass parameters to the class methods and then use them the same as with regular functions. Constructors tell JavaScript how you want your objects to be built. You should now be able to utilize constructors on built-in JavaScript objects. And you learned that inheritance exists in JavaScript, and the inheritance model revolves around the prototype. Additionally, you explored how JavaScript code uses modern features like spread, REST, template strings, and modules. You built code that manipulates the DOM and handles events. And finally, you used JSON in JavaScript. That was a lot to cover, but you should now be more familiar with programming paradigms in JavaScript. Great work.
Thanks you for watching my video, please. Like and subscribe my channel. Thank you for spending your valuable time with us. Your views and support mean the world to us. We couldn't do it without you. Thank you for being a loyal viewer.
In 1886, the first internal combustion engine-powered car was invented by Carl Benz. Soon, there were many cars that used the combustion engine. Airplanes, motorbikes, and boats followed shortly after. People's ingenuity led to using the combustion engine in places that the inventor might not have imagined. The same happened to JavaScript. New JavaScript environments such as Node and NPM are now available. JavaScript's home is in the browser. That's the environment in which it was used for several years. Essentially, it was a front-end only language. Then, in 2009, a developer named Ryan Dahl decided to use Google's JavaScript V8 engine and make it work on the server. It's not always easy being an innovator. Many doubted whether it was even possible. However, the idea caught on, and more people started getting on board. This is how Node.js was born, and how JavaScript became a language for both front-end and back-end. Node.js is a separate, standalone environment. This means that Node.js can run in multiple settings. For example, on the command line, in a desktop application, or on the back end of a web app. Before the introduction of Node.js, developers had to build backends in other technologies and languages such as PHP, Python, C#, Ruby, and Java. After Node.js became available, it was possible to use JavaScript on the backend or on the server side. This means that today you can write full-stack JavaScript programs. In other words, you can write JavaScript on the client and on the server. Node.js comes with a package manager called npm, which stands for Node Package Manager. The package manager allows you to use a large number of libraries and frameworks as Node.js modules. An npm module is a standalone piece of code that has been published on the npm website. Sometimes an npm module is also referred to as an npm package. Okay, so now that you've learned about Node.js, you may be wondering how you can use it locally. Node.js and npm are either pre-installed on your machine or you need to install them. Once installed, you can interact with Node.js and npm from the command line. For example, you can run the node command inside your computer's command line. This is also called a shell or a terminal. In the same way, you can run the npm command. You may be wondering why you need to run those commands. Well, this is because you use the node command to run a JavaScript file or to directly execute JavaScript code. You use the npm command to install any node module from the npm repository. For example, you could install the module named lowercase. Once installed, you can import this module and use its functions to transform strings to lowercase in your code. When you want to start a new project, first open a folder on your machine where you want to place your project files. Then run the npm command. These projects can be different shapes and sizes, but they all have at least one thing in common: the package.json file that gets created after you run the npm command. The package.json file holds all the instructions on all the node modules that are pulled from the npm repository of open source modules. There are about 11 million modules in the npm repository. It means that you can get thousands of hours worth of other developers' coding by running the npm install command and adding the package name. Examples of libraries you can install include React, Webpack, Bootstrap, and Angular Core. The package.json file updates when you install a new package. It keeps track of everything you need to have installed in your project. This makes such projects easily portable. For example, if you have built a project with a specific number of different node packages, they are all listed inside the package.json file. All you need to do is share this file with, for example, your coworkers. They can have the exact same setup on their machines, simply by running the command npm install. This install command reads the contents of the package.json and installs all the necessary packages, also referred to as dependencies. Sometimes dependencies also come with their own dependencies. It often happens that when you run the npm install command, several hundred megabytes worth of node packages get installed into your project, under the node modules folder. In this video, you learned about the origins of Node.js. You should also be able to describe what Node.js and npm are, and how to use the basic node and npm commands on the command line. When you're building something, you want to make sure it works. And you make sure that something works by testing it, right? It's the same with JavaScript code. You need to make sure that your JavaScript code works before you launch it. In this video, I'll show you how web developers test their JavaScript code. By the end of this video, you'll be able to identify the various reasons why a developer would want to test their code, explain how the red-green refactor cycle relates to testing, differentiate between manual and automated testing, and demonstrate an understanding of unit testing. So how do web developers test their code? Let's find out by coding a custom concat strings function. For example, I can create a concat strings function to join any two strings that I give it. In this case, I want the function to join string A and string B that are received as arguments and return the result. For example, I could write concat strings ABC and then DEF, and the returned result would be ABCDEF. When the function receives number 1 and 2, it returns a 3 as a number instead of a string of 1 and 2 together, i.e. 1, 2. I can also signal what I want my function to do by adding comments to it. Adding comments will help my team understand and remember the expected behavior that I had for the function. A more detailed description would be a good way to make it more obvious as to what my intention is for each argument. In the comments, I can even specify the expected behavior when specific values are given to the function. Adding comments is a step in the right direction, but it has downsides. It allows me to write anything I like, so there are no limits on ambiguity. Also, the comment doesn't need to follow any set structure. There are many custom testing frameworks available in JavaScript. One of the strengths of such frameworks is that I don't have to use comments to describe my expectations. The test syntax itself becomes expectation documenting. When I write tests, those tests are a better alternative to comments in my source code, because they specify what expectations my source code is trying to satisfy. Tests are also callable, meaning I can execute tests to check if expectations are met. As I demonstrated earlier, I could execute the concat strings function, with the first argument being the string ABC, and the second argument the string DEF. I would then expect the function to return ABCDEF when I call it. To write this as an expectation, in some testing frameworks, such as Jest, I can use the function that has the name expect. I then pass the call to the concat strings function with the specific arguments. Then I add the toBe function, which is another testing function, and I pass it the value of what I'm expecting this code to produce. So, I'm essentially stating that I expect the calling concat strings with ABC and DEF will return the value ABCDEF. Testing in JavaScript lets me verify that the function is behaving in the way I intended. Testing code in this way ensures three things: conciseness, as it's straightforward and to the point, since there are only two function calls to explain what is the expected result; clarity, because you know exactly what argument you're providing; and repeatability, as you can run it again and again with the same arguments each time. Now, I could run multiple function calls using this syntax. For example, I could have expected concat strings 1, 2, 3 and 4, 5, 6 as arguments, and then the function to be with the argument 1, 2, 3, 4, 5, 6. And in each instance, the expectations will be correct, and the code will behave as expected. In testing terminology, you would say that your tests are passing. But I'm only halfway there, because it's still possible for my code to fail an expectation. For example, if I run the expect method and pass it an invocation of the concat strings function with numbers 1 and 2 as arguments, my expectation of 12 being the result will fail. This is because when I use the plus operator with two values of the number type, it performs the mathematical operation of addition instead of joining the two numbers together to form the number 12, like it would form ABCDEF if I gave it the arguments of ABC and DEF. When tests fail, you say that they are red, and when they pass, you say that they are green. If a test fails, then it's a sign that I need to write the code in such a way that it passes its test. Once my test passes, I need to improve both the app's code and the test code, but without changing the behavior of either. This is known as refactoring. Refactoring is the process in which I write my feature code so that it runs more efficiently, or that it's easier to read and thus easier to understand for other programmers on the team. This is done without affecting the results that the code produces. The only obvious change should be perhaps the test itself, taking less time to run because I've optimized my source code. You won't always write your code in a way that meets all expectations, so it's most likely that some of your tests will be red and some of them will be green. Red tests are a guide as to how you need to improve your code to cater for unmet expectations. So, as you continue to refine your code in response to red tests, it becomes a sort of cyclical activity. This is often described as the red-green refactor cycle. This cycle is the basis of the test-driven development, or TDD, approach to programming. Let me explain the TDD approach. First, you write a failing test. Then, you write your source code so that the previously failing test now passes. Finally, you optimize your source code without changing its results. There are many advantages of having code that tests other code. For example, you can run it as many times as you want. You can run the testing code automatically, and the tests can be repeated without significant cost in time or effort. To sum up, testing is how you verify the expectations you have regarding the behavior of your code. As a developer, you are tasked to test a piece of software. How would you do it? In the next few minutes, I am going to explain what software testing is. I'm going to introduce you to the 3 most used types of testing. You might say that testing a piece of software at a high level means making sure that it behaves as expected. In any modern software development project, these expectations are recorded as software requirements. There are many aspects of software testing, but for now, let's think of it as the act of confirming that it works, as outlined in the software's requirements. Now that I have a working definition of testing, let's think about how you might approach it. For a UX designer, testing might mean making sure that the website looks and behaves as expected. For a project manager on a software project, testing might mean that a specific piece of software works well with other parts of your system. For a software engineer, testing might mean writing code that doesn't break the existing functionality, is bug-free, and satisfies the requirements as set out in a given task. Based on what your motivations are, there are several ways that you can test your software projects. Practically, this means that there are different kinds of testing. Now, I'll discuss the following 3 types of testing: end-to-end testing, or E2E, integration testing, and unit testing. Let's start with end-to-end testing. A real-life example of E2E testing would be if a laptop manufacturer let his employees open some off-the-assembly line laptops, turn them on, and use them just like a normal user would do to make sure that the entire end product behaves as it should. More specific to web development, end-to-end testing tries to imitate how a user might interact with your app. This means that in E2E testing, you need to open your web application in a browser and then test it by interacting with the page the same way a user might interact with it. For example, clicking on the login button or going through the process of adding an item to the shopping cart. In other words, you're testing the entire finished software product from the perspective of the end user. Now here's something you may find interesting. The person testing the app doesn't have to be a developer. Finally, E2E tests are the slowest and take the most time to set up and run. Here are a few examples of E2E testing frameworks available on the market: WebDriver.js, Protractor, and Cypress. Next, I'll discuss integration testing. Integration testing is testing how parts of your system interact with other parts of your system. In other words, it's testing how separate parts of your apps work together. Let's explore two examples of integration testing software: React Testing Library and Enzyme. Integration tests are faster and cheaper than E2E tests, but not as fast or as cheap as unit testing. What is unit testing? Let's have a look. Unit testing is the process of testing the smallest units of your source code in isolation. A good example of this is functions. A unit is the smallest piece of code that you can test separately from the rest of the app. Practically, the smallest unit of testable code in JS is usually a function or a method. Unit tests are self-contained. They're meant to test code in isolation, preferably separate from the rest of your app. This makes unit tests fast to run and easy to write. So, that was a brief overview of the three different kinds of tests. Together, they are sometimes represented as a three-level testing pyramid. First, at the base of the pyramid are the unit tests, which have the highest speed and the lowest cost. Then, in the center of the pyramid are the integration tests, of average speed and expense. And finally, at the top of the pyramid are the E2E tests, the slowest and most expensive tests to run. You are now familiar with the three most common ways that you can test your applications. At this stage, you might be familiar with the concept of testing your code to make sure it's working as you intended. And you might also have come across some syntax of testing frameworks. But what about a language like JavaScript that has no built-in testing functionality? For JavaScript, you can use testing frameworks like Jest. Over the next few minutes, I am going to introduce you to the features of the Jest framework: code coverage, mocking, and snapshot testing. It is quite a mouthful, so let's get started. JavaScript doesn't have built-in objects or methods that would allow for tests to be written. Therefore, many different libraries have been built to tackle the issue of testing. Some examples of these libraries include Jasmine, Mocha, Carmen, and QUnit. And then there is the one that you'll cover now, namely the Jest testing framework. Jest is a JavaScript testing framework. It's often used for testing code like React, a JavaScript library maintained by Meta and a community of individual developers and companies. Besides plain JavaScript and React code, Jest allows you to test Babel, TypeScript, Node, Angular, Vue, and various other frameworks. Jest also supports code coverage. Code coverage is a measure of what percentage of my code is covered by tests. If I say that I have an 80% code coverage, that means that only 1/5 of my entire codebase is not covered by tests. But even 100% code coverage doesn't mean that you have tested for every conceivable expectation. It just means that there are some expectations tested for each line of my code. Still, code coverage is a handy tool to gauge the amount of my codebase that's included in tests. The higher the code coverage, the lower the chance of having unidentified bugs. As a rule, the higher the percentage of code coverage, the lower the amount of time required to write new tests. This, however, depends on whether there are incomplete software requirements pending, or if you are going to receive more requirements in the future. Next, let's cover the concept of mocking. Mocking allows you to separate the code that you are testing from its related dependencies. In other words, you can use the mocking features to make sure that your unit testing is standalone. For example, you can test the front-end functionality of your web app by mocking the data as if it came back from a server, when in fact it came from the client. Mocking is especially helpful because very often web applications are built by teams of developers. Some developers work on the back end of a feature, and others work on the front end. This could result in bottlenecks. Take an example where the team decides to build a new feature that lists the address book of users of the app on the front end. The actual user-related data for this feature would come from the server. But what if a back-end developer was a bit late in developing their part of the feature? Then a front-end developer would be stuck waiting for the back-end developer to complete their work before the front-end code can be built. With mocking, you can avoid this bottleneck. Mocks allow you to pretend that the users are already there. So, the needed data comes from the mock rather than from the back end. This allows the front-end developers to finish their side of the new feature independently. In certain cases, developers can use mocking to ship features faster. Some libraries, such as Sign-On, focus specifically on mocking. But the great thing about Jest is that you use its mock functions without any additional installations. In Jest, you use mocking by employing Jest's mock functions. It's also easy to test asynchronous code in Jest. There are no difficult setups, and tests are relatively easy to code, even for newcomers to the framework. Finally, Jest allows you to perform snapshot testing. Snapshot testing is used by developers to verify that there are no regressions in the DOM of our apps after some changes to the codebase are made. You're now familiar with the concept of testing your JavaScript code using the Jest testing framework. Great work!
In this video, you'll explore how to install the packages needed to test your JavaScript code in the Jest framework, as well as how to set up a test. Let's say I need to write a function that takes a value and adds 5 to it. I'll start by creating a new file and naming it add5.js. The code in the add5 function starts with function add5 and then val in parentheses. In between curly braces, I have return val plus 5 on the next line. And then on a new line, I have module.exports equals add5. This is a simple function which will make it easier to analyze when I write tests for it. I've also added a line to export this function so that it can be used by other files in this project. Now I'll switch over to using the Jest testing framework to write some expectations of how this function should behave. Before doing so, I'll check if I have Node.js and npm installed on my system. In the Terminal tab, I type node-version to check for Node.js, and it shows that I have version 16.15. Now I check for npm, and it tells me I have version 8.5 installed. One more step before I continue is to check if Jest is installed by typing jest-version. In this case, it returns command jest not found, meaning that it is not globally installed on my machine. So I'll install it for this project using only npm, since Jest needs Node.js to run, and npm is a way to install Node modules into my web projects. I'll first type and run npm init-y to add a package.json file. The -y flag automatically answers yes to all the questions the init command asks during installation. Now I have my package.json file. In other words, I have a way to keep track of Node modules that this project depends on. Since I want to use the Jest testing library, I'll need to install it locally, which means installing it for this project. So I run npm install --save -dev jest. After a few moments, the package.json file will be updated with the addition of the Jest testing library. I also have a folder called node_modules, which is where the code for all the modules in this project is stored. In the package.json file, I'll need to make a few changes to the script section. In the test entry, I replace the text that is assigned to test with Jest within double quotes and save it. Now when I run the command npm run test, it will run the Jest command in this folder. So what does this Jest command do? It runs tests for the code in my project. Right now, I only have a single file, add5.js, so it makes sense to create a test file for this one JavaScript file. I'll name it add5.test.js. In the naming convention I use, I add the .test just before the .js section of the file's name. To set this file up, I'll first import the exported add5 function by typing const add5 equals require, and then in parentheses, /add5 backtick. The reason for the / is to indicate that the function is in the same folder as the test file, and I've omitted the .js because Node understands what I mean even if I don't use it. So my expectation is that this function returns whatever value I input plus 5. To check, I'll use the test method with a string as a parameter that describes the test. This string will be output in the command line when I run the test, along with the words pass or fail and the function to run when I execute the npm run test command. The function will check if my expectation is correct. The string will be output in the command line when I run the test, along with the words pass or fail, and the function to run when I execute the npm run test command. The function will check if my expectation is correct. So I have test, and as the first argument, I have the string returns the number plus 5, which is what I want to output on the command line when the test is run. Then, as a second argument, I have a function which checks my expectation. I'll save and run the test, and I get back a pass result. In this video, you learned how to ready your system for testing in Jest and how to set up and run a test.
Every piece of software is built according to formal or informal requirements. The purpose of the requirements is to explain, in human language, the intricacies of what the piece of software does. So, how do the requirements tie in with the practice of test-driven development? Let me explain. Test-driven development, or TDD for short, is a streamlined process of writing code that will satisfy some requirements. Let's unpack this process a bit. On a high level, a software development team's work consists of the following: receiving requirements which will become a feature of the app that's being developed, writing a failing test for the to-build feature before it gets built, making this failing test pass by coding that given feature. In comparison with the traditional development process, the TDD approach might seem somewhat upside down. I am now going to demonstrate the TDD approach by writing a failing test for a JavaScript file and then writing code to make this test pass. To understand how TDD works, consider the following real-life situation. Suppose you have to perform a task. Drive your car to work. You leave your house and walk up to your car, only to find out that you don't have your car keys with you. Then you remember you left your car keys in the cabinet, and you simply forgot to take them. What you did there, in this imagined scenario, is the opposite of TDD. You first walked to your car, and only then did you check if you had your car keys. If you did these things using the TDD approach, you would do the following. First, you check or test if you have your keys with you. Your test fails because you don't have them. They're in the cabinet. Then, you perform the action of getting your keys from the cabinet. Finally, you check or test if you have your keys. This time, you have them, so your test now passes. What is described here is the essence of TDD. Let's go through these steps again. This time, pretend that you're implementing TDD in your code. Imagine that you need to write code in a test-driven way. Since you're coding the TDD way, you first write the test, even before you've written any actual implementation. For example, you test if a function named status of keys exists. You then use some testing functions from a testing framework. Since you haven't written your source code implementation, the test fails. Next, you run your test. The test fails because there's no status of keys function declared. The logic of your test code is, expect that the function status of keys exists. In your source code, you declare a function named status of keys. You run the test again. It checks if there is such a function and it confirms it exists, so the test passes. It's important to note that one of the rules of TDD is that you should write as little code as possible to make the test pass. For this test to pass, it's enough to just declare a function with a name. Next, you receive another requirement, which is as follows. Accept a keys variable, which should be set to true, and console log the keys variable. So, the requirement states the status of keys function should accept a previously declared keys variable, which should be set to true. The status of keys should then console log the value of the keys variable. So, you write another test, which fails again. Since you have yet to write the implementation, you write it, and your previously failing test now passes. Finally, you examine your function code and realize that the indentation is all wrong. There are also too many unnecessary comments. So, you clean up your code and run the test again to confirm that you haven't accidentally made any errors. The test still passes, so everything is okay. That is the TDD approach in a nutshell. Let's go over it one more time in a scenario. As a member of the development team, your task is to read the requirements for the software that you are writing. The requirements are passed to you by the project manager, so you get your first task for the day and start coding the TDD way. First, you read the new requirement. Next, you write a failing test. Then you update your source code so it resolves the requirement. After that, you run a test that passes. Finally, you refactor your implementation. This process is usually explained in 3 words: red, green, refactor. Red represents the failing test. Green, on the other hand, represents the passing test after you make updates to the source code. The refactor represents the final tweaks to the code that don't change implementation details, which can always be confirmed by running another subsequent test. When implemented correctly, TDD brings huge benefits to an organization because it allows for automated testing. In any platform, projects grow bigger over time and become complex. Making sure that all the tests are passing is a strong signal that the current requirement and all the previous requirements for this piece of your app have been delivered successfully and that nothing is breaking. Test-driven development has many advantages. Here are a few. With TDD, you are minimizing regressions, that is, accidental bugs introduced to old code by coding a new requirement. And you also have proof that your new implementation is not breaking other parts of the app. You can automate these tests easily and thus keep verifying again and again that the system works as expected. You can test your implementations with various inputs, and the tests become a specific kind of documentation for the new members of your team. In this video, you learned how test-driven development, or TDD, works. You also covered the steps involved in the TDD approach, and that it is implemented in red-green refactor cycles. You've completed the Testing and Compatibility module. Well done. In this module, you got an introduction to code testing. This was an insight into how web developers test their JavaScript code. During this module, you explored the importance of testing, and you examined JavaScript testing methods. Let's finish up now with a recap of the material included in this module and summarize the content by focusing on the key learning points. The history of the development of the JavaScript language was outlined, and you learned that today it is possible to write full-stack programs with JavaScript. You should now know how to describe what Node.js and npm are, and install and set up Node.js and npm. In any development environment, you need to check that your code works properly before you move to the next phase of its development or release a completed program to users. An example of using the concat_strings function to join 2 strings served to demonstrate how commenting can help to indicate your code's intended behavior and how testing in JavaScript verifies that a function is behaving in the way that it was intended. Having completed that section of the module, you should now be able to identify reasons why a developer would want to test their code, differentiate between manual and automated testing, identify and describe the 3 different kinds of testing, and explore the features available to web developers within the Jest framework. Additionally, you should be able to understand the concepts of mocking and snapshot testing, explain how to test JavaScript files with Jest, and demonstrate how to write a unit test. You've put a tremendous effort into getting this far and gained some critical skills by learning about the need for code testing. You've also explored various methods used for JavaScript testing. Great work. You've completed another key part of your software development education. Keep the learning momentum going and be sure to join me for the next module.
Thanks you for watching my video, please. Like and subscribe my channel. Thank you for spending your valuable time with us. Your views and support mean the world to us. We couldn't do it without you. Thank you for being a loyal viewer.
In this course, you discovered how to program with JavaScript. Let's take a few minutes to recap what you learned. In the opening module, you discovered real-world applications of JavaScript and uncovered possible job opportunities. You also learned how to install VS Code on Windows so that you could code in JS. You then learned about the importance of JavaScript in programming and the different libraries used by JavaScript developers. As you progressed through the lesson, you encountered key concepts in JavaScript. By engaging with these concepts, you discovered how to identify and declare variables, differentiate between data types, and recognize math and logical operators. You also learned how to perform basic arithmetic using the number data type and utilize strings and Booleans. In the next lesson, you explored conditionals and loops. During your exploration of these concepts, you learned how to script different forms of JavaScript conditional statements and work with different types of loops, such as for, while, and nested. In Module 2, you explored the building blocks of a program. You began this module with a lesson on arrays, objects, and functions. During this lesson, you learned how to explain the purpose of functions and describe their benefits, outline the process for building an array and accessing its contents, and you now understand the array characteristics and concatenation operators of strings. And you can now also build and call functions, create custom objects, explain how math objects work, and interact with arrays and objects. You then moved on to the next lesson, in which you explored the concept of error prevention. During this lesson, you discovered how to recognize the differences between bugs and errors, demonstrate try-catch blocks, and explain the concepts of undefined, null, and empty string values. The next module on programming paradigms began with a lesson on functional programming, in which you learned how to explain how the functional paradigm works, outline the concept of recursion, describe how scope operates, and explain different forms of scope such as let, const, and var. In the next lesson, you explored object-oriented programming and learned the principles of object-oriented programming, how to deploy classes in JavaScript, build and utilize constructors, and make use of inheritance. You then explored advanced JavaScript features, in which you learned how to destruct arrays and objects, utilized for-of loops and objects, explain the concepts of template literals and data structures, and demonstrate the use of the spread and rest operators. Finally, you then explored how JavaScript operates in the browser. During this lesson, you learned how to manipulate JavaScript in the DOM, make use of JavaScript interactivity in the browser, work with events, and capture and move data around the web. In the next module, you looked at testing and compatibility. The lesson began with an introduction to testing, in which you learned about the concept of testing and how to practice different types of testing, how to write a unit test, the process for writing tests with Jest, and how to apply test-driven development. You then reviewed JavaScript testing challenges, in which you learned how to navigate other JS environments like Node and NPM, the concepts of Webpack and transpiling, the process for working with arrow functions and classes in React, and you discovered the role the DOM plays in testing challenges. And finally, you discovered how to write tests with Jest. Well done on completing this recap. Now it's time to try out what you've learned in the graded assessment. Good luck.
Thanks you for watching my video, please. Like and subscribe my channel. Thank you for spending your valuable time with us. Your views and support mean the world to us. We couldn't do it without you. Thank you for being a loyal viewer.
Congratulations on completing the Programming with JavaScript course. You've worked hard to get here and developed a lot of new skills along the way. Let's list some of the key skills you've gained. You began with an introduction to programming, and you should now be able to explain the capabilities and uses of JavaScript, describe the background and history of JavaScript, explaining the importance of ECMA and ECMA script, and describe JavaScript libraries and their uses. You then received an introduction to core concepts of JavaScript coding and should now know how to code single-line and multi-line comments with semicolon syntax and using variables, data types, operators, numbers, Booleans, and strings. You further extended your coding abilities by writing statements using conditionals and loops, using arrays, objects, and functions, and enabling error prevention in your code. Programming paradigms introduced you to functional programming and object-oriented programming, advanced JavaScript features and the operation of JavaScript in a browser. And finally, with testing and compatibility, you discovered the purpose of testing, explored types of testing, and studied JavaScript testing challenges and testing with Jest. Congratulations once again on reaching the end of this course on programming in JavaScript. You've taken a valuable step on your journey toward becoming a developer.
Thanks you for watching my video. Please like and subscribe my channel. Thank you for spending your valuable time with us. Your views and support mean the world to us. We couldn't do it without you. Thank you for being a loyal viewer.